So welcome to our second day of the Trusted Summer School. Today, the day will be fully dedicated to the application layer. And we will have with us Wageningen colleagues from the Trusted project. So first, I would like to give the floor to Mireille van Hilten with a presentation about the application area. So Mireille, when you want.
Sure, thank you. Good morning, everyone. So after a nice introductionary day yesterday, I think you have kind of an idea about the three layers, or we sometimes call them area. And today we want to do kind of a deep dive into the application area. I'm gonna just try to put a little bit more weight on what the application area is about, also in relation to the other areas or layers. And then we'll have two more sessions today to give you a better idea. First, I would like to, I know I introduced myself yesterday. I want to just say a little bit more about myself now that I have the floor. So I'm a researcher specifically on the domain of information management, or we can say business informatics in agri-food with economic research. And feel free to drop me an email if you have any questions to me directly. My email address is in this PowerPoint. And just to share with you a little bit about my background, I'm involved in several projects, national as well as on the European level. Trusted, of course, the blockchain is really a theme that I work on, but I also work on other themes. So, for example, data optimizations for organic certification. It's not specifically blockchain, but it is kind of like an improvement of how we do certification for organic food here in the Netherlands using more digital sources, data sources. I've worked on the topic of digital twin and also in the project called IOF, Internet of Food and Farm 2020. With a focus on getting the users to really accept the tools that we offer and that we developed in that project, which is a large-scale European project with 33 use cases in agri-food, specifically focusing on Internet of Things technology. And then I'm also involved in a more robotic type of project. It's kind of aligned with IoT, which is called AgroBoFood. And that's in that project I'm involved in making sure that the network of everybody involved, all the stakeholders in robotics and agri-food, are aligned and can provide services to each other. So the aim of that project is really to make sure that the innovations are sustainable. So not just prototyping and experimenting and then maybe not finalizing and using the solutions on the longer term. So really making sure that these innovations get implemented very well and are here to stay. There's a publication I would like to point out to you, which is Blockchain for Organic Food Traceability. I've put up a link there. So that's an article that I worked on specific, I think most relevant for this project, which is why I'm mentioning it. And a little bit about my background. I used to be an ICT lecturer for two different universities of applied sciences. So that's kind of, if you think back about the lecture that Patrick provided yesterday on the career with the T-shaped profile, that's kind of, I'm pretty broad on the top bar of the T. Because of this background in teaching, I'm familiar with many topics. And then my specialty is really more into business process management and now also blockchain and kind of where process, end user, and technology come together. So those three are essential elements in any emerging technology project, I would say. So I hope that kind of gives you a background of where I am now and also links a little bit to the session on careers yesterday. And if you have any questions, just feel free to open your mic or send a chat message. So the three topics I want to go over in the next 25 minutes or so are the following. So first, let me take you into the blockchain application landscape. So yeah, we talk about verticals and we talk about themes. So how can we, and maybe it's also an answer to one of the questions from the session yesterday, but in which ways can we apply blockchain in agri-food? And then the second topic, I want to position blockchain a little bit more in relation to other ICT, I say ICT, information communication technologies, which is another huge domain. It's like opening up another can with lots and lots of detail in it, but I'll try to give you an overview there. And then the third topic is the perspective on the intermediaries that are involved in this ecosystem of a supply chain or a food system, and how does that work? So I'll take you to that topic as well. And firstly, just to make sure that we still have the 3 layers in mind, we'll be focusing specifically on the application area. And also you see here that the certifying entities are mentioned specifically, which is what brought me to the idea of discussing this today. And again, here we have quite a linear view on the application area, but keep in mind that it can be quite complex. All these actors in the supply chain are interlinked, and that's exactly where blockchain can provide value. So first topic, blockchain application landscape. So when we talk about verticals, just a little bit of definition, we refer to it as a business vertical or a market, but it's basically the term that we use to describe a specific industry that focuses on a particular niche. We have a couple of verticals where blockchain is applied to. Of course, we're in this summer school mostly interested in agri-food. And what we also see is we can combine verticals with industries and sectors. Sometimes we use these terms interchangeably. And examples of the verticals that we have, of course, are banking and financial services. And I already mentioned yesterday that that's one of the verticals where we see a lot of blockchain application. And then the other ones like energy, government, well, I think we're all familiar with that. But we can also, the bottom one, certification, we can also see that one as a specific vertical. So we can be really creative with how we consider these verticals. And some of it's not an exhaustive list. Some of the sub verticals that we work with a lot in agriculture are, for example, fisheries, forestry, and then farming. We can break that down even further. Livestock, fruit and vegetables, arable. We could put horticulture here. I see my colleague Koos has also joined. He'll be talking about horticulture in a little bit, which is another subsector. But also agricultural insurance and land registrations are all, I think, yeah, good examples of where blockchain is already being applied. The other way to look at blockchain applications is by regarding the different types of themes. We also saw already some of these yesterday, but if we talk about identity management, self-sovereign identity, Gero spoke about this, is a way to use blockchain to make sure that the identities of the actors, of the individuals involved in the blockchain are well protected. And the authenticity is another way to work on identity management to detect fraud and counterfeit. Another way is transparency. We talked about this also yesterday, but just summing it up. Transparency and traceability are also used often in the same sentences, but are really not the same thing. Transparency is often aimed to provide information to the end consumer or even to other actors in the supply chain, so that everybody knows within the supply chain the information about a product or what types of plant protection products were used. So that's something that Koos will talk more about. And traceability can be traceability about the origin of a food product. It can also be traceability about the location of a food product. So it can even be traceability of data. So they're used the same, but they're not the same. And then accountability, auditability is more about who is responsible for which treatment of a product, for example, throughout the chain, or who is responsible for a certification, or, well, you can think about many examples. And then efficiency. I spoke a little bit about that yesterday as well. Efficiency can be really aimed at low cost and high yield, for example, or high profit or whatever. But in this sense, when we speak about blockchain application, we see as disintermediation is also a type of efficiency, because you really take out the central control in a supply chain. And I will be coming back to that with my third topic just in a little bit. And then efficient workflows. Yeah, so the blockchain really makes it possible to track and trace transactions and make workflows more efficient. And it's also a way to automate certain steps. So I hope those themes can maybe help you think about how to view applications. So maybe when Koos is going to talk about FloriChain not this afternoon, this morning, maybe you can keep these themes in mind and try to think about which themes are really coming back in his presentation. I showed you this slide already yesterday, and I want to take a little bit more time to go over it. The application landscape in agri-food, we have many examples here on the slide, and we see that the drivers for working on a blockchain use case or creating an application or starting a project are really different. So on the left side, we see the 3 Ps, people, profit, and planet. And we try to map our use cases, the most familiar use cases that we have. We could try to map them there. For example, the Nori use case is a case that uses blockchain to trace, to track and trace carbon sequestration. So that's when farmers put carbon back into the soil, and they actually get paid through their blockchain system for putting carbon back into the soil. So it's not a carbon credit trade system, but it's really about putting carbon back. You can check it out on nori.com. It's a nice use case. So that one's focusing on planets and has the farmer as one of the main beneficials, actually, because they can have an extra means of income if they log on to this blockchain and make sure that their efforts to put carbon back into the soil don't get unnoticed, and that they can actually be paid for that. So that's another example, in addition to fair food that I talked about yesterday. We do see other examples. So we have the Walmart, Carrefour, retail, and Albert Heijn is the Dutch retailer there. They're really focused on consumer information, also on supply chain management, kind of on the boundary there. And that's where the IBM Food Trust platform comes in also, because that's the blockchain that is used, for example, for Walmart and Carrefour. So that's how you can map these different applications. So this provides quite of an insight into the reasons behind, or the drivers why these organizations start to use blockchain. And of course, each organization, for example, Carrefour, represents the whole supply chain that's behind it, right? So it's not just one organization. So imagine the entire blockchain ecosystem behind each and every logo here. And then if we take 4 of those themes, supply chain management, farmer-centric, environment-centric, and consumer communication, and spread the use cases that we have in our database, spread them across the world, then we see them really everywhere, from North America to South America, Australia, in Europe, but also Africa and in Asia. So supply chain management, the blue dots are well represented. We see some farmer centrics and even some environmental centric. So I think the supply chain management is more present here actually. So that kind of gives you an idea of where we're at for blockchain applications and themes. So my next topic, and I don't see or hear any questions, so I'm just going to move on, is blockchain in relation to other information and communication technologies. So if we look at farming, there have been many advancements. We can, of course, use sensors and drones and soil scanners and everything to know better what's going on the farm and around the farm. And that's kind of the first step that's called sensing and monitoring. And we can move to the next step using AI and other data science methods to make sure that we analyze the data that's coming from the farm. And then the farmer or other operators can start planning the next steps on the farm. And then we get to the next phase, which is the control phase. So let me give you some more visuals with that. So we see many examples of smart sensing and monitoring in not just in arable farming. We have lots of examples in arable farming, but also in vegetables, dairy, and meat, and fruits and vegetables, by the way. So yeah, we know examples of autonomous tractors, milking robots for cows, the drones. We have satellite data on fields. We have weather data. So yeah, we're working on many projects where we combine these things. And I think the idea is that getting to the third phase of the smart control, where a farmer can use actuators to really remotely operate objects, so a tractor or irrigation, without him actually having to do it with his own hands and going into the field. That's the final step, if you like, that makes the circle go round. And the more access we have to data, and the faster that data is connected between sensors and systems and humans, the better we can become at closing that loop. And that's yeah, the big data is really central to all of this. Another way to look at that is the cyber physical management system. So blockchain in relation to all of these advancements in farming, we could say it's a core technology within such a cyber physical management cycle. So the same cycle that I talked about on the previous slide, yeah, blockchain can really be a way in many different forms of applications to can be key to that. And we can even take that further, moving away from the farm level and going on into public decision-making level. So this data in an aggregated form can, so certain types of reports can be very, very beneficial to public decision-making. All right. This is another way to help you look at the data that gets produced in the food chain or the food value chain. So we have we have data input from the producers, from the farmers, or we could have it. And the data validation is on the right. And I'm sure Koos will also speak more about data validation today. Yeah, it can really give us a lot of insight on what's happening in all these different steps, from pre-processor to processor to transportation. So, and yeah, then maybe a nice remark is that even if we have all these data, it will still be quite the challenge to make good use of them and connect them. It's well known that even in other verticals, other companies, let's say transportation, there is so much data available. Maybe companies only use like 10, 20% of what's available. So there's a lot of progress to be made, and also in agriculture and food. This is an overview that I really like when we talk more about traceability. So if you look at a food traceability information system, we see the kind of linear approach that I talked about yesterday, from the farm all the way to the consumer. But I think it gives an idea on the different types of traceability that we have. So Yesterday, I spoke a little bit about external and internal traceability. An organization doesn't just want to log and track what they do when processing a food item or a crate of cucumbers, but also the external traceability is quite important. And you see how many organizations are involved in sharing this information to be able to create complete chain traceability, the line from going from left to the right. And underneath, we have all these food safety and quality regulations that also need to be aligned, actually. And I think that's the whole challenge. And on the top, you see wireless identification and sensing technologies, location-based technologies, information and communication technology. So we have to make all of these come together and create a good information flow alongside the transportation and product flow. So just summarizing that topic, so IoT and blockchain, precision farming, we were well involved in many projects, can lead to higher yields, lower inputs, and more sustainable food production. And then we have smart sensing that can make us really move a step forward in achieving high product quality and sustainability and reduction of waste. And with that, we can use blockchain also for access management technology for IoT scenarios. And it could also lead to, we can overcome IoT security issues. And IBM, our IBM colleagues have previously talked about crypto anchors in other sessions, which is a way that we can make sure that specific products can have a crypto anchor which cannot be tampered with. And that crypto anchor can move along the supply chain. It's a way to track that in combination with blockchain. Smart contracts, also something that I think Koos will talk about more. Using smart contracts, we can make sure that we know where a product is coming from, the provenance. Privacy is a way to make sure that we can, with smart contracts, we can ensure privacy and have a positive effect on the verification and authenticity. We also call that zero knowledge proof. So zero knowledge proof means that you don't have to actually know personal information about somebody, for example, but it can be, the blockchain can have that information and just provide a yes or no for a verification for a specific person. So if, let's say you want to get a loan somewhere, if we use a blockchain system, it would just be a check if you are who you are, or if you have a certain level of credit, without providing the actual information to the organization that's providing the loan. So that kind of gives an extra layer of privacy to it. And adding to that, once we have next generation connectivity, so 5G and 6G, the smart farming control phase, or the third phase that I talked about, it can work even more efficiently because data will be exchanged more rapidly. And there's still a lot of issues with connectivity in rural areas and making sure that, it's these three loops, or the entire loop of all these three phases for smart farming are accessible to all farmers. And I'm running out of time, so just very quickly on certifying bodies. So let's say we have organic oranges and we are tracking them through a blockchain. It can be very beneficial because we now have many different types of certification. We have tampering with labels, and we want to make sure that our food is authentic. For example, an organic orange. Then how does that work with blockchain? And very shortly, you can see very well on the left and on the right, the current supply chain has information flows between producers, processors, and food services. And with the blockchain situation, all these actors use kind of the same blockchain layer in which they track this information. And that makes the intermediaries basically unnecessary. So in the case of an organic orange, that would mean that we don't have to certify each actor in the supply chain saying, yes, they're verified organic, because we're already logging that information. That's not as easy as it sounds. I think Koos will talk about that, because we also have to make sure that the checking of each step at the actor level is really verified. Is it really an organic producer? How can we make sure that the information that is logged onto the blockchain is correct? So the data going into the blockchain has to be verified, right? So that's a challenge. But the point here is that the intermediaries, they may, I don't know, disappear, change roles. And that is an interesting perspective from blockchain, about blockchain. So just to summarize the application area, I think you have an idea about what we're talking about, especially in addition to the session we did yesterday. And Koos will talk more about a blockchain application called FloriChain. And this afternoon, Lon and I will talk about how to develop a blockchain application for a successful use case. And I'm not sure if we have any room for questions, but that was my part at least. So I'm gonna end the screen share. Maybe Nuria, you can step in here.
Yes, thank you very much, Mireille. So now we move to the presentation, second presentation we have in the morning. As Mireille was saying, with Koos van der Meij from Wageningen Research too, and it will be about blockchain experiment experiences. So welcome, Koos, and thank you for participating in the Trusted Summer School.
Thank you, Nuria, and it's a pleasure to share some experiences of the last years with you all. I will start sharing my screen.
We can see it, just that it's not in presentation mode yet.
Yeah, so it's switching on my side now to presentation mode.
No, we still see the edit mode.
Oh, okay. Then I have to do it this way.
Maybe it's a question of the screen that you're sharing.
Yes. One moment.
Mm-hmm. In the meantime, I would like to say that the next lecture in the afternoon, just for people that maybe cannot attend till the very end, will be on another link, because this will be a more public lecture with people that not are just early stage researchers or people from INL. So we will send you a new link later on and by email.
Okay, so I try to. I think now it will be in full screen.
Yeah, perfect.
Yeah.
Okay, great. There we go. So for me, it's the first time to enjoy the summer school. I work a lot together with Mireille and Lan, so I'm informed about the summer school and the experiences. Today I want to start with sharing the experiences of our site about innovation with ledger technologies, and we did a lot experience, as I said, the last years, and it's learning by doing. And what means learning by doing, we will go through the topic in this presentation. So I split it up in two parts. So I have a view about supply communities I want to share, and decentral validation. And the second part, we had a short coffee break in between. It's about the FloriChain. Mireille already mentioned, it's the data ecosystem. what we're using for plant production, pesticide registrations, and a lot of more. And we do that more on an interactive way. We have that application in an online area where we can join all with a username and a password, where we can insert some pesticides, and I will give some explanation about the horticulture chain, how it works, and I have some videos added also to have an impression about that amazing area. Good. The agenda for today, as I said, we had a short coffee break in between. We started with why decentral validation is a must for DOT applications. And then in the second part, we have the demo of the front chain application. So let's start with the introduction. I'm in the same group working as Lan and Mireille on Wageningen Economic Research as a part as Wageningen University in Research to work. We are in the part of the social science group, and my role is business development for WECKE, and specific to the topic data and ICT in the agri-food. And data is a part of big data, and the big data is blockchain is also a part of the big data and data area. And the last 2 years I've zoomed in on validation for blockchain technology, and why I did, I will come later on in this presentation. So I know a few. I think you all mentioned this topic. So if you are too busy, that we are not open for innovations, and it's even for a blockchain. The quote of today is: if you don't change the way we work, then blockchain will never work. Well, the summer school has a topic for the food, so I will specify some food parts. I also saw it in the presentation of Mireille about fraud. Well, there are a few actors how food fraud will start. Well, one of them is it is a suitable product. The other part that are motivated actors, and there is a lack of control measures that are free actors, which for food fraud will start, and makes it really weak on that part. So the last years, even Lan has worked out with the NAN a lot of experiences on that. How can we use blockchain to becoming safer data, safer areas for food by using data. It's about validation, it's about accreditation, and they are all needed to get into a approved area. It means that we have focusing on a new data ecosystem, because there are more actors involved in the whole area. It's about compliance. It's about, on the part of the governance, how we interpret laws and regulations. Because if a data ecosystem is changing, it has also a lot of effect on how you had the system of the law, the system of the governance, and it's about norms and standardization. But even as blockchain is a part of data and big data, you cannot use blockchain on the right way if you don't have standardization and if you don't have norms to do that. Well, about data ecosystems, if you look to the industry 4.0 model, that we see all that now we are in the third part of this model, and it's mean about computer and automation part, where we have the data ecosystem. And so in the next coming years, we will convert to a smart data ecosystems. And it means that we have more and more the influence of cyber physical systems. We have about machine-to-machine communication, and on a few parts we are already on the fourth part. So we are in between the third and the fourth part. That means that we entering a new level of the industry model, and yeah, there it starts with the smart data ecosystems, and how do you organize a smart data ecosystems, and how do you validate and accreditate data, and how do you prove that machine-to-machine communication is working well on the right way. It's not about only standardization, but it's also about cybersecurity and that part. So if you look to the linear supply chain system, you are working out a lot of now, and this is an example of a food chain. In the data ecosystem, we are all putting to all the chain partners information. And if you do it on this way, there is no problem, because everyone is sending and receiving the data. And so for the whole chain, the information for everyone is well organized. But it's a theoretical part. What we see in practice is that if we start sharing data through the whole supply chain, it works well until there is one of the suppliers in the chain who is not well willing to share the data and the information, or not willing to share all the part of the data and information. And then you get a lack of data in your supply chain, because it stops over here. And now you are asking for a supply chain, what's the added value of the data for the whole supply chain? As you see over here, it's for a few actors, it's working well. But if you are on the as a supply chain partner in the end of the chain, for in this example, then you don't have the information, and you need to run your processes in a data ecosystem. So that means that the role from a supply chain has to be converted to a supply community. And as you see, you have the same actors in a supply community. The only thing is that it's another way around organized. There will be in the middle one central, let's say, coordinator who is connecting and converting all those players with the information and the data set they need. And it means that it's sharing a network of a lot of parts. If we talk about Internet of Things, if we talk about even blockchain, if we talk about robotization, machine-to-machine communication, it's all needed to be shared. And you can share it on a different way, like LoRa, like Bluetooth, BLA, Bluetooth Low Energy, even Wi-Fi and internet systems. And the most important thing also is that you have some information system and information dashboard which is fittable and suitable for the whole supply community. So that the important thing for that, I mentioned also before, that it's needed that you need standardization still, and GS1 is one of the parts. International who are starting up new standards on this, but also keep going on existing standards. If you look to the horticulture area, there is Floricode, and Floricode is one of the parts who is defining all those standardizations on the way we can in this chain all communicate quickly and on the same part. And those parts are connectors, mostly API driven. So, well, what's the situation of today? It's that we generate a lot of data, and data is growing and growing. And even if you look to Internet of Things device, it will mostly double the year, like Moore's law, and it's not still now. It's not ending, it's really on the part that we're starting with Internet of Things devices. Even on Internet of Things, I will focus on sensor data and image data, because that are few streams which are the most fast growing from data volume the past years and even the coming years. So if we look, sensor data are there on a lot of different ways. I have an overview with some examples of sensoring which are over there. It's sensoring on all levels, which are used by Arduino boards, but also on high-end computers. We all know the smartwatches, as you know that your heartbeat can also be mentioned. There are 7 sensors in a little smart Apple device, and every new Apple Watch variety will have 1 or 2 sensors more, or some added value to existing sensors. So the last developments are flexible sensors. You can use them as let's say, a second skin. It's used and tested specifically for the medical part. But we see with sensoring a lot that it starts on the medical area, and when there's enough volume and the price is compatible to use it also for other areas, that it will come over to other sectors. But how are you starting with this volume and this all type of information about Internet of Things collections data? How are you organized? And there are 3 main pillars to organize and to do it in the right way. It's starting with standardization, and there are a few standards for sensor development you can use. One of them is a global standardization of GS1, the FSIS, and it's all connecting wherever you are in the world, information and Internet of Things. I can use the standardization to share information in that way. But it's not only standardization, it's also about management, and also about explanation of which these data values will be and will mean. For example, if you have in a truck a few sensors who are registering the temperature of the indoor location of the truck, and the truck will start with pick up some parts. They open the door, and your sensor of the temperature on the back of the truck will directly give an alert, because the sun is shining over there, and it's running out about a few degrees on the maximum level. So also that are kind of rules you need and to implement in a management system of sensor management. And the last thing, it's about security. I have an article, sorry for you all, but it's in Dutch, but it's about 2 years ago that there was a research of the University of Twente that they explained the DDoS attacks we have in the Netherlands, that how more uncontrolled Internet of Things systems we have, how more DDoS attacks we have the last year. And as we see that the Internet of Things solutions will grow the last years, it means that also the DDoS attacks will grow on that part. So that's a part also. Security is really important to have standardization, because security is hard to manage if you don't have a good standardization part on between. So one of the other things is image recognition. we all know the autonomic driving cars. So there are a few big companies who are developing, who had developed the last years a lot of new techniques to use computer vision. I think Tesla is one of the parts started years ago with the LiDAR technology. And that was for me an interesting thing, because when they started with image recognition and when they started with LiDAR technology used by computer vision, we didn't know what the outcome will be a few years later. The thing we know is that image recognition will be becoming more and more useful for a lot of things. And that's what we see now, for example, by Google, that there are a lot of free tools you can use for image recognition. If we look to self-driving cars, it's also about the growth of machine learning. So the combining of and the translation of image recognition, computer vision, that will have more and more outcomes for machine learning and more data for training on machine learning, and more experiences and new insights the coming years even. And that's also what we expected the coming years, that we have a lot of data information about the part of imaging. So, and what does it mean? We had on the part of where we went out 2 years ago with the Horti Radar project. The Horti Radar project was a tool which is scraping on the internet Twitter feeds, and the Twitter feed about the topics of the horticulture part and fruits and vegetables. And by detecting all those feeds, we developed a tool which is which has a machine learning forecasting model based on NLP, natural language processing. And this part is detecting all the feeds by the word of food, specific on a top 10 word, like bananas, like tomatoes, all that kind of information. And we did a forecasting tool about if people are tweeting a lot about on Twitter, a lot about, let's say, some things they are not amused, or if there's a disease on tomatoes, as we had and cucumber a few years ago, then this tool will send an alert when a tweet stream will when a tweet stream expected is to exploding on tweets. So on that alert, we had all the information about the main words in this part, like the explanation of the diseases. So for policymakers, it's really interesting that they have an alert in before there's really a problem with this part. So it's also based that we translated this from NLP to image recognition. So because image recognition, then you don't have the translations in all the different languages because they are uniform and you can use it on that way. So this is one of the examples. We started with NLP, and on the end we work with computer vision and image recognition. It means also that we can detect main colors in pictures, and for the horticulture it was really interesting how we can approve the new trends for the coming years by scraping images on let's say expositions, images of expositions of design companies. And all this information you can use starting forecasting. So this is what I said about the Cloud Vision API of Google. You can use it for free there's a lot of detection and a lot of information. On the work, we work out with our colleague Rick van der Zedde about phenotyping, and with the phenotyping machine, every growing in the glass house, every plant has a detection by day on individual part. So it's all scanned on this way, as you see, and they are plotting the plant on a 3D image scan, and it's detecting a lot of diseases, but even the shape of the plant, the condition of the plant, and all that kind of information. So even over here, we are starting with collecting a lot of image data. So related that all kind of information and data to blockchain. I had over here a little film what's about blockchain, but it's not for this session because we had already a lot of experiences how blockchain work and how it is. So as you see that every block consists a number of data, and I don't know why my screen is switching.
We still see your PowerPoint, Koos.
Yeah, but even I don't see it now. Yeah, okay, it's back again. It all started with a Genesis block. The Genesis block is once a time. It's the first block without the previous hash. And if you look to the easy description for blockchain, it's a block number and a nonce and data and a previous hash, and that's the outcome of a hash. So there are there are a few online demo tools if you want to experience something about how blockchain work, how a hash will be, how a block will be, and how a blockchain will be. You can scan this QR code. It's a free online blockchain demo. You can run your data. You can insert data over here, and you can see how a blockchain is translating your data into the blockchain nodes. Well, the first blockchain we had in Wekker, we started in 2017. It's a project of Meij, Christopher Brewster, Jacob Speck, Anton Smeek, and Jan Top, colleagues of WUR. And it was about blockchain for agriculture and food. Well, it was the table grape case. It's about labeling. They say it's 100%, let's say, a fair trade or biological or whatever. On a lot of fruit parts, there are those kind of claims and logos. That it's really, let's say, for the avocados that you, it's ready to eat. But how do you know that? How do you validate this, those kind of information? And so it started all with the compliance. It started with standardization, and this is a model of Farm Digital. How a area will be in the agri-food and with the knowledge of all of us in 2017. Well, the thing which is really clear that if you look how the streams are going on through all the chain for table grades, and all those kind of certifications, all those kind of checks, all those kind of information to have a logo or to prove a claim or to have the certification on that, is really a complex situation. And if you plot the whole landscape into a blockchain area, it's more on this way. It's more easier, it's more approved, it's more sharing information and validation on products.
That's great.
Well, this is a lot animation about the application.
We present the Blockchain for Agri-Food tool.
This report documents experiences and findings from the Public-Private Partnership (PPP) project Blockchain for Agri-Food that was started in March 2017.
Show you how Farmer Steve then transfers ownership of both batches to Trader Bill. So now here, being Steve, we see that we have authorization for both organic and fair trade, organic from Bob and fair trade from Carol, with the timestamps and the fact that both capacities are true. We're now going to create the batches. We're going to have one batch, Steve 1 of 100 kgs. Show you how Farmer Steve then transfers ownership of both batches to Trader Bill. So now here, being Steve, we see that we have authorization for both organic and fair trade, organic from Bob and fair trade from Carol, with the timestamps and the fact that both and then what we'll do in the last column here is we're going to transfer ownership. He can still assign fair trade, but not organic. We're going to transfer the ownership again of the same batch of grapes to Bill as a trader. So we can still certify fair trade and pass over ownership to Bill.
Well, as you see, this was the first application we built where we can have some the monitoring and the track and tracing of products and applications. And on this part, if the table grapes are organic or fair trade produced, because it's also about people are well willing to pay something more about fair trade, but how do you check that the label fair trade is really fair trade? So this is where we started in 2017. It's about certification and ownership. So we want to demonstrate how a distributed network will work with databases, and how the findings of the added value of the blockchain are also based on fraud detection and prevention, and about the value of certification through the whole chain and a complex chain where a lot of information sharing points about certification. How do you convert all those information on the right way? So for a start in 2017, this was really for us an interesting thing. We learned a lot of, and it was also on the same time the new question. Okay, if we bring all this information in a blockchain, how do we validate and verify this information? Because I love the technology of blockchain, and I really especially the functionality of smart contracting. But what is the added value of smart contracting if you don't use it on the right way? Because as we saw the explanation of the tool of the table grape parts, we can manually select if a part is biological or if this part is fair trade produced. And that's great because you can add that information in a trusted area where it's transparency, and you cannot change this information because the protection of the blockchain technology shared by a lot of nodes and checking if the information is right. But if you are manually in the situation that you can insert whatever you want, what is the added value of that kind of technology? So I started looking about fingerprint for validation. And we worked out already in Wageningen the mini MRI scan of one of our colleagues, Alderik Velder. He developed by the mini MRI, detecting the fingerprint outcome, what kind of molecular structure a product has. There was a project we were involved in, Canadian, about the DNA barcode scan. In the DNA barcode scan, they did a lot of genes registering of flowers. We had a collagen scan about over there. You can detect some information about which animal it is. And we had the molecular scan in general. And all those outcome, it doesn't matter which technology, but it all is generating a fingerprint plot. And that fingerprint plot is really unique for molecular structures, for example. So I used the example of the blockchain demo to explain what does it mean about validating. Because we have in the data set, we have the Internet of Things part, we have incoming data, and we have outgoing data. And in between over there needs to be a part of validation in between the incoming and the outgoing data. So if you look to products verification, on this way you start a blockchain. You have a technical improvement and you have an algorithm to bring it in, and it will be shared on a blockchain network, as you see on the right. But why is decentralized validation interesting? Because if you have a decentralized validations, it means that all the partners in a blockchain community agree that validation is done on the right way, and that criteria are shared in general decentralized with all the partners, and checked on all the nodes that values are really the values you are allowed to use, and you can connect that value, that validation, to the technical applications you use. In the past slide, I showed you the example, for example, of molecular scanning. So the outcome of molecular scanning, you were registering in a decentralized application, and everyone knows that if you have an outcome of that part, that is based on that values which are decentralized visible. So you cannot use a decentralized validation in a traditional database environment, because every part you checked decentralized, it's still editable if it's in a traditional database. If you look to the DLT environment, as we use a lot of times without validated input, you had a situation, as I explained from the table rape part, that you can manually add all the information you want. So for that, it's really on this part in the middle that you are combining decentralized validation to have a really transparent technology, a track and trace through the chain by smart contracting. And all the information is really unadaptable. And if you combine those information with decentral validation, then you can really run machine-to-machine communication and even product verification and certification in that way. So if you look at the technical varieties, there are already DNA barcode scanners. A DNA barcode scanner is a little handheld application. You can put 1 millimeter of a product part piece into those scanner, and it's checking on the database which information you are detecting. So if we talk about meat, you can see if the meat is really from horses or really from cows. All that kind of checks you can do. So about fraud and detection, this is one of the tools you can use for that. Maybe a few of you know also the SCIO. SCIO is a handheld scanner. You can use the SCIO combined with a Bluetooth connection with your mobile phone. For example, you download the application of SCIO, and it's working with spectrophotometer technology. And that means that it's sending some laser beams to a product, and you get it back, and it's generating a molecular structure. And so you can detect on an apple, for example, which the brick score is of an apple. That means if it's sweet or sour, all that kind of information without cutting out some part of the apple. So the consumers are now in the position that if they have a SCIO and they are in the supermarket, that they can detect on this way the fruit they like or the fruit they don't like. If it's on their taste, you can use your own profile. So it means on this part, it's about the Meij score, it's information. But even later on, you can detect, for example, if there are some parts of pesticides on an apple. And that's really a part why validated certification is needed and why technology of blockchain is needed. So the mini MRI I already mentioned, it's developed the last year by Aldrich Velder. Now he is working this out because now it's scanning and storage the data, and the data set has to be converted on a computer-based system. So it's not still on a standalone handheld, but that they will work out the few coming years. And yeah, that means if you convert from a supply chain to a supply community, that even the governments is part of those communities, because all those food information which is coming out, they also need for the inspectors of the government, and also are needed for the inspectors of the certification organizations. And the interesting thing of the of having a handheld tool like a SCIO is that a consumer pay for the instrument, and it's free scanning data. So for your machine learning part and training part, you have consumers who are paying for a tool and deliver you also free scan data. That's an interesting topic. So 2 years ago, Changhong H2 is a mobile phone where the SCIO was built in. And you see over here in the top, there's a little part of a scanner position. And that's an interesting thing, because now you don't need a standalone handheld. You have your mobile phone to detect in the supermarket. And I think most of all, you don't go to the supermarket without your mobile phone. So you are collecting over there a lot of information. And as you see on the left, you can scan the grapes about how the taste will be from the grape, from the apple, This is an example of fruit, but you can also check, for example, chocolate, how many cacao is in a chocolate. You can scan like chicken, how many water is in the chicken, all that kind of information. And the price of those mobile phone was 2 years ago about 380 euro. So that's not really that kind of investment. You have a mobile phone and a photospectrometer in this part. And they are selling about 3 million pieces a year. So the data of this, I don't say that the 3 million are all used daily by everyone, but it delivers you in return a lot of data information and a lot of training part on that. Yeah, so this one I already mentioned about the government. Also, the government can use those scans by inspectors to do a quick in-field scan. Well, on the other hand, in 2018, Greenpeace did a few checks on pesticide research when it was Valentine's Day. They bought a few buckets, and the buckets, the bouquets, they checked on pesticides, and even the outcome was not that good, because it was sold as a fair trade bucket, but they found pesticides which are not allowed on this product. So the confidence of the retailer related to the consumer is really hard, and they didn't know that as a retailer, because they paid even more to have a sustainable product, but what was delivered wasn't really sustainable. So on that part, you see that it's really more and more needed not to do a certification audit one time in a year, but to have it more and more on a piece level part. So, and if you look how a validated landscape will be, so it all starts on the left under the picture, that you have a production line, and on the production line you put a molecular scanner, and the scanner over there will directly detect if all the values are allowed for those products. By image recognition, they know which product it will be. It's an extra validation. And in the decentral validation database, they can check if the values are in scope for this certification or not allowed. And it means that you on product part can generate directly a certification for those products on piece level. And you can add a unique ID to this, to those batch, and you can register it all in blockchain technology. And if you then have the situation in the supermarket that it's approved on this way, and people are using their mobile phones for information and about scanning with a molecular scanning like a built-in Skio, then you have really a validated landscape. And then you will know that if it's free from pesticides, and you have checked it, it's really free from pesticides. So this is about trust and approved trust. So if you look to the simple view over, it's about the smart certification compatible part of contracting for blockchain technology, that you do the same techniques, you have the algorithms, but you put a layer on it with smart certification rules. And on this way, you can check on sustainability on the government. If it's really in scope of the rules, they don't need the inspectors anymore. It's proved for the business and it's proved for the consumers. So this way you have really a smart contracting part, how you want to have it in the blockchain, validated, trusted, and in the database. Well, for a community, it's a win-win, because if you look to the circle of community, that if you do the product scan on piece level, you have a blockchain pesticide stack, so you are on piece level sure that it's free of pesticides. Well, after that check, you can generate a smart contract certification on piece level. That's really a customer guarantee you can give. And if you have, as a grower, as a retailer, this customer guarantee, you can invest more because you don't have less claims and you have more guarantee. You can invest for this supplier on the grower part to be more and more sustainable growing their products. So this is for after the coffee break. My suggestion now is that we have a 10-minute coffee break, and then I will start with the next part of the Flore chain and the background where we start.
Okay, thank you very much, Koos. Very interesting all that you have explained.
Thanks.
So we go then for the 10 minutes coffee break, and
Yeah.
we come back at the 10 hour time, 30.
Yeah.
11:30 your
Yeah,
time.
even if there are now still some questions, we can do it also, but we can do it also start with the questions after the coffee break.
Okay, perfect.
Okay.
So see you in 10 minutes.
Koos, je audio staat nog aan.
Ja, klopt.
Oké.
Ik kon er even niet bij.
Dat je het weet.
Oh, hij zit hier. Hij zit...
Oh, nu niet meer.
Hi, Mireille.
Hi. How many people do we have in the meeting? Just about?
We are about 24, yeah.
Okay.
Yeah.
Hey, Koos.
Hi.
Hello.
So, I think, Nuria, I can go further on?
Yes, let's start.
Okay, thank you.
I don't know if you want to go, if there are any questions for the moment, or leave them for the end.
Yeah, we can. So for me, it's okay to do them also now. If there are any questions now, we share your questions. Feel free.
Mm-hmm. Any questions from any of you? Just feel free to open your mic if you want to ask, or yeah, you can also write them in the chat anytime.
Yeah.
That's for shy people. But also fine. No, but really, it can become more interactive if you ask your questions. Just pop on the video and open your mic.
Mm-hmm. Okay, so then we can maybe continue.
Yeah.
It's all very clear.
Thank you. I want to jump now over to our PPP blockchain. We have two cases on this, but it's the onion case and it's the flower case. I will zoom in on the Flore chain application. So as you see, we started for plant protection products, plant protection products, I have to say. And we had a few parts which are out of scope of, in Dutch we call it the PPS, but it's the PPP, the public-private partnership. And so one of the parts out of scope is really how you can use finger scan applications for identification, how we can use Internet of Things solutions like a smart sprayer. So we have it all in mind as a follow-up, but it's out of scope of the PPP. Yeah, if you look how certification in the moment works in a supply community or a supply chain at the moment, that there are a few organizations who have a flower and plant certification, and one of them is MPS. And MPS has a few classifications about different type of certifications. It's about production, it's about pesticides, it's about how you use your gas, how sustainable the energy is you use in your glass house. And if we look to the chain, it's starting with breeding. You have over there the roots and the young plants or the seeds. Then they start growing. After growing, they will cut the production and prepare it to bring it to the auction. On the auction, there are trading companies who are buying the flowers and plants, and they are transporting that to the flower shops all over in Europe, the world also, but 98% will stay in Europe. And 89% will stay in Europe, and then the consumer is the end of the chain. And if you look to certifications, it's really passed on the part of the breeding in the chain and the part of the growing, but then it stops. So you see that there after the production and the auction, it's only that they have the certification label on the product, and for the whole chain we all agree that okay, this certification is related to this type of cultivating of the flower or the plants. It's an audit once a year. For some certifications twice a year. So it's really an impression of that moment, and it's not an indication on product level for the whole chain. And that started with the idea how we can get a value creation with blockchain technology for that. And the thinking was, how great will it be if we can have a smart sprayer system? And it means that you need blockchain technology. It means that you need some validators to authenticate and to have the accreditation of which liquid you use for the pesticides. You don't need longer the traditional audits by samples, 1 or 2 times a year. And the new role of a certification organization will be is that they have to deliver a quality label on every device, on every smart sprayer. So that's really a new situation in a smart data ecosystem. Well, if you work out that smart sprayer, let's say, yeah, it's not really an ecosystem. If you use smart sprayers in an ecosystem, it has also some other outcomes. It means that if you are using on this way which pesticides and in which volume you spray, that you also have a exact monitoring about the stock of the products you have. It generates chain information about all the data you have, let's say about the diseases, because there's also a camera on the prototyping, and the camera is detecting diseases in an earlier stage because it has a specificer view than a human eye. Well, it means also that we get a new role on quality marks for certification, and it's bringing a lot of more information for the whole chain of how you use plant protection. And if you can detect in an earlier stage with a camera view that the plant is recovering of a disease, you can automatically reduce the pesticides you use for that disease. So you only, it's more on that way, it's more sustainable. Well, it's more, as mentioned, it starts with a new role for certification organizations, because they don't do the audits once a year, but they have to be the check on the tools. So it means that the core business of your organization will switch to new applications, and there is some help needed to that organizations how they transform in this smart data ecosystem. Well, on that part of validation, we started a patent, and it's still pending until last year. Then we have the outcome for this. It started 2 years ago. And this will be our next step to work out the concept we developed after the PPP for the blockchain. Well, it's using a molecular scan. It's using image recognition. There's a GPS tracker, and there's a flow meter for using the volume. And on the handle, there will be built in a fingerprint scan for humans, which means that by having the handle in your hand, it's automatically recognition of the human, if that human is a registered human and has the license to use that pesticide. And if it's not starting up, and it will not work. Well, if we work out on a sketch the process, it is on this part that we have a camera view on the end of the spray handle. It is detecting the flower, and it's using the cloud Google Convision which type of flower it will be as a detection tool. You can use Google Cloud, you can use computer vision, that doesn't matter. And we have a result with a unique tag for the product identification. And that kind of information we want to share as a JSON result, as an API web service outcome to the public API of CTGB. And CTGB is the Dutch organization where all the pesticides are registered, and also all the information, how many times you may use it and for which product it's allowed, is an automatically scan. And the outcome of that is that if you use this pesticide for that disease, you may use it in this volume and this frequency and all that kind of information. And it's detecting this for the whole chain. So even for a breeding part and also for the grower part. And that outcome, it will check with the molecular scan if really the product is related with the molecular fingerprint to the computer vision outcome of the product. So we did also the coffee break. I was too early, I see now. But I wanna share about the flooring chain, because as I said, those which I presented of the PPP, that was out of scope, and that's the follow-up of the flooring chain. And in the flooring chain application, we started by developing a connection with web servers validation by CTDB, the organization of the pesticide use registering in the Netherlands. And we have a connection with ERP systems of growers who are registering in their ERP system and that kind of information. And this is one of the slides Lan already presented you those week of last time about the checklist. It's more as a wrap up what was the flooring chain application. And I want to start with a little video about the breeder, what breeding really will be.
Over the last 4 years, we've been developing our trait and technology pipeline, which is now fully delivering traits to be launched to the market. As a first step in this pipeline, we work on gathering and developing genetic resources.
Our trait discovery team focuses on developing groundbreaking novel traits in wild species and making them available to our commercial breeding programs. We perform several experiments to investigate our genetic resources for traits which are important for breeding, including resistances to pathogens such as fungi, bacteria, insects, and viruses. Our phytopathology specialists focus on the performance of bioassays to identify sources of resistance and to test them under the most harsh conditions so that we are able to make sure that our intrinsic varieties can withstand the most harsh conditions. Our trait exploration specialists also focus on improving traits such as vase life, transportation resilience, heat and drought tolerance, plant architecture, flower morphology, multiplication rate, rooting ability, and future product forms. In many cases, the sources of resistance are not easily available for our commercial breeding programs. Therefore, one of our main activities is to develop and maintain a large scale of genetic resources, and with the help of our cell biology specialists, then we can exploit these true gems of nature. Artificial intelligence helps us in implementing image-based phenotyping in a large set of plants from our breeding programs. With the obtained information, we can support our global breeding programs by providing new insights into our genetic material. With this, they can make better crossing designs and better decisions that will allow us to have a more efficient, reliable, and faster breeding progress.
When such a novel trait is targeted by our trait exploration team, the trait genetics team comes into play. They study the heritability of the trait and develop molecular markers for effective breeding later on in the research pipeline.
We use genomic data to develop molecular tools to support the discovery team to screen large numbers of plants for the pathogen load. We detect whether a plant is being affected by a pathogen, how severe the infection is, and which pathogen is causing the infection. We offer our breeders molecular selection tools and resistance genes to predict whether a plant is resistant or susceptible to a specific pathogen. These tools are applied often as early as the seedling stage, which is more cost-effective and faster than performing greenhouse pathogen tests.
With more and more information becoming available about our crops in relation to the traits they harbor and their genetics, we open the possibility for floriculture to move into the era of predictive breeding.
We are developing tools to make recording phenotypes faster and more reliable. Phenotypes could be traits such as disease resistances, strength, yield, and even consumer preference and ornamental quality. By using deep learning, we extract meaningful phenotype information from large numbers of images. We predict the phenotypes of a plant long before we can observe it. And even better, we predict the phenotypes of possible offspring between plants, such that the breeders know which crosses to perform and which crosses they shouldn't perform. This modular approach means that we can apply technology from small to large crops and for traits influenced by a single gene, such as disease resistances, to traits influenced by thousands of genes, like strength and post-harvest quality. All of this information is available in a condensed and easy-to-use way.
With novel traits developed, we rely on cell biology and physiology specialists to allow access to the traits for our commercial crosses. Our scientists develop methods for fast breeding cycles and mass propagation to be applied once the targeted new varieties have been developed.
The major challenges and distinctions of breeding companies are how they generate, maintain, and exploit genetic variation. Here within cell biology, we help breeders to access the natural genetic variation which was beyond their reach without the help of technology. For instance, embryo rescue techniques are used to lift reproduction barriers within wild species and commercial cultivars to transfer resistant traits those have been lost during the domestication process. Also, ploidy alteration and double haploid technologies provide tools to breeders to stabilize and exploit genetic variation. Biological processes are used to shorten the plant life cycles by speeding up plant developmental programs. For instance, culture media with right amounts of nutrients and hormones and good light and temperature conditions can be used to significantly reduce the plant life cycle during the breeding program. Combination of faster culture conditions and faster molecular selection processes provide breeders the methods to fastly integrate novel traits within commercial breeding program and fastly launch the product to the market. By utilizing totipotent nature of plant cells, it is possible to regenerate whole plants from single cells. Large plant cell cultures provide amazing opportunities in plant culture. They allow mass production from smaller starting material with automation opportunities. Large-scale in vitro production processes also provide ultimate hygienic levels without the use of harmful chemicals.
Now having facilities to match our ambitions, we are ready. Ready to deliver new varieties with groundbreaking traits which can make the floriculture industry flower sustainably. With innovations like powdery mildew and agrobacterium resistant roses, rust resistant chrysanthemums, powdery mildew resistant calanchoes and TMV resistant petunias, we can safely say we are just scratching the surface. With over 70 active research programs and more than 50 traits under validation, we are ready.
Well, this is some explanation how breeding work those days, and as you see, there's a lot of technical and a lot of lab information, which has the outcome that they can, in a shorter life cycle way, develop new products which are also more sustainable, which are need to use less chemicals. And that combination of reducing pesticide use in blockchain technology combined with all this molecular information means that you can have some parameters on the molecular part to validate all this kind of information. And you can show to the consumer that by using this technology, the use of less chemicals and pesticides is the effect of the new way of breeding. So this is an introduction to the next step in our tool. Yeah. So now we can. My suggestion is to start up the live application demo for pesticides. I have prepared a use case that you have the role of a breeder. The name of the breeder is Plantize. If you scan the QR code, you are directly forwarded to the online entrance of the tool. And you can use on the left in the green blocks, you can use the username and the password, and you can easily insert for those use case an example of so you can do it on a few ways. If you want a really a realistic use case, there's an example in the blue part that you insert 1,000 pieces of the product Hebe Donna Britta. In the tool, if you open the tool, it will start up in Dutch, and on the right you can switch to the language in English. And you need to insert, if you logged in, you have to insert those information of the VPN. That's the product registration number of Floricode, and the number 321782 is related to the Hebe Donna Britta. You can use that as an example. One of the pesticides you can add is the Emax deltametrin EC25, and you can insert the volume, you can insert all that kind of information. And if you have inserted that part, then the tool will automatically check this information by the API services if it's allowed, yes or no. So if you use it exactly on this way, it should be allowed and it will be approved by the technical part. And if you want to check if it works, even if you insert something which is not allowed, you can free enter all other kind of information on that. So I think now we have 5 minutes to insert all of you this kind of information into the tool, and then we go back to the role of a trader and the role of a grower.
Okay. So I'm just following the steps as well, Koos, if that's a good idea, I'm not sure.
Yeah.
Yeah?
Yeah.
Me too.
Login worked. So we'll give everybody some time to log in.
Is it an idea if you share your screen, Mireille?
Yeah, I'm on my mobile, but I can do it
okay.
again. I'll try.
I think then I have to stop sharing now. Huh?
Wait, I'm not ready.
Okay, no.
Me neither.
Because first I need, okay.
Yes, please wait a minute.
Yeah, I'm logging in on my web browser, but just to make sure, if you want to log in, I'll put the information in the chat as well.
The thing for me is that it appears in Dutch. I don't know.
Yeah.
Yeah, I can see that it continued to English. Yeah.
There's a little globe on the top right corner to change the
Mhm.
language into English.
And where do we insert the 1,000 pieces of product? Where do we have to go?
Yeah,
Do we click on the flower? On the name of the...
Because I've clicked to switch the screen.
Okay, I'm putting the login information in the chat. I think you have to click on the Hebe Donna Britta. And from there, I'll start sharing my screen and see what we can do. Okay. So, Koos, should I share my screen?
Yeah.
Okay. putting it in English first. Oh, then I think you have to stop sharing first. So you should be seeing my screen.
Yeah.
So we logged in. I changed the language to English right here, where
Yes.
the green globe is. So if you haven't done so, any of the participants, it's easier in English probably.
Exactly. You see there's already something insert. If you click on the left on buy.
Here, buy.
Yeah. And then over there you have to, yeah. So the code, the voorcode product code, it is, one moment, the 321782.
All right.
Yeah, then you have an ID of the seller.
And what do I fill in?
It's addenda, ADDANDA.
Yeah, I'm just also doing it in the chat.
Yeah.
ID seller is addenda. Okay.
Yeah, and seller is also addenda.
All right.
ID seller, you can use a specific user ID for a seller. Well, the item number over here, it's the 321782.
3217.
Sorry, the 1000. Sorry.
1000. How many
1000.
items I want to buy?
Yeah, and the item name is the Hebe Donna Britta. You see it on the left on the screen also.
Okay.
Yeah, sorry, it's over here. The item name is Hebe. Sorry, only Hebe, Mireille.
Okay.
Because that's the group name. Yeah, and the Hebe Donna Britta is the variety.
All right.
And then if you go down.
Just a second.
You can scroll down now in so the number of units are 10 and the quantity per unit is 100.
So it's like 10 crates with 100 flowers.
Exactly. Yeah.
Okay.
And then you can select the date, expected receipt date. So that's when it's expected that the product is ready.
Okay, just a second. So I'm copying it into the chat if people want to do it at their own pace. Expected receipt date. Does it matter what I select?
No, you can use today.
Okay.
Yeah, and the amount it's 1000.
Okay.
In description, you can add your personal information like test Mireille or something.
All right. Do we call it an app or is it not an app?
It's technical. It's not an app. No, it's an application, but it's not the app in the way it can. But you can use it as an app also on your mobile phone. And then you can, if you can push the green button down at the bottom. Well, and then you see that the purchase is executed. Now we insert this information. Now we have this part. If you close those screen, then we go to the part of the grower because that's the next step in the chain. So as a breeder now, I've prepared this batch. It's in the system, and later on, as a grower, we add some pesticides also on it. We can do it also by breeding, but then we have less to do on growing. So I think it's good to do it in the next step.
Okay, so just so I understand, it's this line, this first row that I've added. Okay. And the blockchain system accepted the insert of this
Exactly. Yeah.
data entry. Is it like a transaction?
Yeah. If you click on the right, you see a vector.
You mean the arrow here?
The arrow, yeah.
Mm-hmm.
Over here you see all the information about this part. I think this is not the right one because there's no name on this.
Yeah, there are a couple of
Yeah.
of these, so I'm not sure which one it is. Maybe this one.
Yeah, I think so.
Oh, this one's already been treated, so let's not spoil it. Mm-hmm.
Yeah, that's difficult if you are with more than one users. Then we have a lot of parts, but we see that all the batches are inserted with the amount of that part.
Mm.
Then later on, as we have the row of a grower over there, we will see those batches
Okay.
already.
Is it easier if we then switch to your screen?
Yeah.
Okay, I'll stop sharing.
Okay, so I'll share the screen again. And then we go to some explanation about how growing after the breeding, how growing will work. And it's about the product chrysanthemum. Something stopped, so I have to restart. Well, this is the next step in the chain, and you saw something about the process of a grower. Yeah, you saw that the glass house is really amazing. There are a lot of flowers in it, and for that it's necessary that you has to do a lot of automation in this, and you need robots, you need computers, you need machines, and all that kind of information. And as you saw also for chrysanthemum, it's really important that there is no infection in the soil, and that's why they steam it. So steam is really a sustainable product. It's not a pesticide, and there's a lot of effect to protect for fungi. But as you saw also, they used traps to have the flies. They use biocides, and for a few parts they still need to use some pesticides. And that's the interesting thing, that even for a breeder, it's sure that the starting point of this is that they get the young plants from the breeder as really little plants, and they need to guarantee that there's no infection in that, because they steamed the soil. And if you don't have a healthy product with the guarantee from your breeder, yeah, then you never receive a nice flourishing product. So that's the next step in the chain, that you can log in as a grower, and the name of the grower is Addenda. That was the name we also added in the information where we bought this part. And over here we can add some pesticide use. The pesticide use is Profume. It's 1 dosage mixes with 12 letters of volume. And then if we have inserted that, we sell 100 pieces of the 1,000 to the auction, Royal Flora Holland. So the username and the password are different over here. The URL is the same. So if you are still on the URL, you have to log out, and you have to log in with the grower. But you can also have a look when I will ask Mireille to share again the screen, and we do it together to show how the process of a grower works. You are muted, Mireille.
Yeah, I noticed. Okay, give me a second to log in.
Yeah.
And I'm also adding it to the chat again. I think we have a question also, Koos, if you can, while I log in, read the question.
So I have a question related with the genetic information we integrated in the BTC. Will the, for example, resistant genes to certain pathogens identified in, let's say, a seed will be included in the provide info? No, in this PPS, it's this information is not in the blockchain added. We have only registered the use of the pesticide and related to the product. The things that we have registered on the main settings is that we know the location. Every glasshouse has a unique location identifier. And in the glasshouse, you have several batches you can use, so you know which product are from which batch, and every batch will sold in one. So for every batch, you know the pesticides and the volume which is used on that batch. So let's say if you have a part of 1,000, there will be 10 batches of 100. So for every batch we have an insert of the data which is used on pesticide and which volumes. Okay, I think
I'm logged in, so if you stop sharing your screen, I can share mine.
Yeah, I will. There's one question I will answer now. How can we simplify the information to the normal consumer? And that's a really good thing, because those part that we have, it's really useful for the business part. The things we struggle with is that we stop at the auction over there with the chain we have simulated in those PPS. And the step after that, that's really interesting. How are you forward those information to the consumer? We are thinking about using pictograms on that, and to have a identification how sustainable a product will be, easy with pictograms. But it's out of scope for those PPS. But it's really a good question.
Yeah, and it relates to, sorry, Koos, if I can add, Gero also mentioned yesterday that as an end user using a blockchain application, you'll interface with the system on a mobile or on another device, and you don't really notice anything much different that it's a blockchain system in the background, right? As an end user, for the consumer, it's even different, because he's only reading the information, assuming that he's not adding any information to it, which is also a scenario. So yeah, very valid question, and I think today is more about giving you an idea of the way that different roles work in the same system and how transactions are logged and visible. And then at the other end of the consumer, you can unlock that information in any way you like. So yeah, nice question.
Yeah. So you can share your screen, Mireille.
Okay. There we go. I'm just zooming in a little bit, changing the language into English. Okay, so I am a grower now. Yeah,
and I now can, because we had a few times 1,000 amounts, so I don't know if you scroll to.
No, but I can maybe use another one.
Yeah.
So I guess it's not the full list that we see on this dashboard.
No, if you scroll to the up. Yeah, so let's open the that one, and you can click on the right. Oh, sorry, can you go one step back?
Sure.
Because this is the part of breeding. I think if you scroll down, then we get the growing, and over here has to, yeah, if you have this pot plant accepted, the first one. If you open that one, now you can see on the left you can add a pesticide.
Okay.
And over here you can insert it's the Profume, Profume.
Yes.
Yeah, and product description, you can use it on the same. Dosage is one. Product number you can leave empty.
Okay.
Dosage units. you can also leave empty. Then the water volume is 12. Scroll down. And then it's the treatment step. I cannot. I have the small videos on that part, so I cannot read what's.
Oh, okay. So what do we do for concentrate?
No, yeah, you can liter, a hectare.
Liter per hectare, yes.
And if you click on the type, you can. I think we don't need them to insert now.
Leave it blank.
Yeah. And treatment step.
Yep. I accidentally hit the enter key, so it's telling me that it's a required field.
Yeah. You can enter pot plant.
Pot plants.
Yeah. And the plague is the name of the disease you are using, and you can insert test disease or something like that. I don't.
Test disease.
Yeah, test. A test.
Test.
Testing. Yeah. Because I'm not a grower, so I don't even know for which disease you are using this. And then you can select the date of today also.
Right, so leave control type code empty.
Yeah.
Okay, just a second while I copy it to the chat. There's a question for you in the chat by Aljon.
Okay.
You can do that in the meantime, maybe.
Yes. Utilizing device blockchain can tell more on consumers' perspectives and the sellers' sales as well. Yeah, do you mean this in the perspective of this tool? Yeah. And so what we want to first we want to achieve is that we have the transparency in the chain. So if you have we are talking about business to business, from a grower to a consumer, from a breeder to a grower. And from the breeder to the grower, it's really necessary that you have the right information and the right validation, because now a lot of times they are all bring it in automatically and insert it manually. But that's the first step to really have your system and your chain in control from the data flow. And to bring it to the consumer, it's another level, because it's really about communication. How do you translate the information of pesticide on the right way to a consumer? What does it mean if you use, for in this example, the perfume? Where do you use it for? And what did you achieve? And I think that's what we see in the little video of the breeder, that by developing on this part, by using molecular scanning, molecular technologies, that you can have a more resistant young plant. It means that you use less pesticide. But if you don't explain the difference between that to the consumer, it isn't worthwhile. It does say nothing to the consumer, because they still see that there is a use of pesticides. So I think that part is more about not only this is the technical side of the tool, and to bring it to the consumer, it's really about consumer experience, which user interface you need for a consumer. It's about communication, and that's really a step to go. Usually you can add your name, Mireille, or my name, or whatever you want, and then you can submit. Well, now you see that we have registered this part. If you see the timeline, then you see directly that the treated crop with perfume is done, and you see now the clock on the left is blue, and that means that the API, the web service, is now checking if this part is if this pesticide is allowed to use in this perfume. If you see in the timeline the treated crop for fungal flesh, it's denied, and you see that even why, because CTGB has denied the treatment. So that's the feedback of the API, that this kind of fungal flesh is not allowed to use in this dosage for this part. So with this whole timeline and report, you have the whole history of using pesticides, and even if parts are allowed, yes or no. So we are working in the testing mode, but one of the questions we still have in this PPP that so if it be that we have used the fungal flesh and it's denied, the treatment is denied by CTGB, so what then? What are you going to do? For example, if you sell this to a retailer and this product is on the blacklist, it is filtering out this product of the list of products you want to sell to him. So on that way, that he has the guarantee that he always has a product which is exactly in the scope of his products. So we have built a blacklisted, so every retailer can add his conditions on the blacklist, and even the tool is checking that he will find only in the database the products which are fitting in his conditions. So maybe you can refresh one time the page to see if the web service has checked something.
Okay, refreshing the page. I hope everybody got to do the same steps, because I was typing in all the information in the chat, but it was only to you, Koos.
Yeah, no, and you can also test this later on, because it's the whole week available to, and even next week. So
okay,
if you now,
the info is also on your PowerPoint, right? The things
exactly,
to
yeah. If you scroll down, now you can see that the API did his check, and even it's denied for this part, because perfume is a part you can use always for chrysanthemums and not for the Hebe. So he did a check on that, and you can see that it's not allowed to treat this part if you want to work with the blacklist and the conditions. So if you close your screen, then we go to the last step of a trader, and it's not only the trader, it's also the auction, because the flower auction is the central hub where all the products arrive and where the traders are purchasing their product. And I start with a short video with the explanation of the flower auction.
Okay.
Are you going to start offering your products via Royal Flora Holland? We warmly welcome you. Congratulations on your choice. We are going to sell your products at the auction clock. We shall support you with getting your product into the best marketing position. In this video we shall show you how products are sold at the auction clock and give you some practical tips. You will also become acquainted with one of our buyers. The clock is one of our marketing instruments and has been over for 100 years. Each day 3,000 Dutch and international buyers purchase at the export clocks in Aalsmeer, Naaldwijk and Rijnsburg, and at the florist clocks in Eelde and Naaldwijk. You will thus be offering your products for sale in the largest marketplace in the world. We connect our members with their buyers. Become acquainted with one of your buyers.
We kopen dus hier de bloemen in. 's Ochtends lopen we door de bloemen heen. We kijken hoe de kwaliteit eruit ziet. Eerst checken, daarna naar de koa-ruimte. Ja, en dan gaan we vanaf hier eigenlijk online inkopen. De klant is inderdaad heel tevreden als hij krijgt wat hij vraagt. Ja, en dat is voor ons natuurlijk ook zo. Ja, en dat is natuurlijk ook het makkelijkst werken. Ik bedoel, het gaat allemaal steeds sneller. Het is allemaal real-time. We hebben verschillende klanten. Kijk, voor de groothandel is het niet zo'n probleem. Als er een keer wat aan mankeert, dan zijn ze niet zo moeilijk. Maar we doen ook retail. En daar zie je gewoon dat wat er gezegd wordt, moet er ook echt op staan. Dus de lengte, het gewicht. Als het de keten ingaat, dan is het niet zo dat wij alleen een probleem krijgen met de kwaliteit. Dus dat we die bloemen moeten vergoeden. Maar als het eenmaal in een boeket gaat en het komt er later uit, heb je ook kans dat je een claim krijgt van het hele boeket. En dan zijn de gevolgen veel groter. En ik wil ook niet zeggen dat als wat aan mankeert, dat de kweker het met opzet doet. Maar ik denk dat het gewoon voor ons en voor iedereen heel belangrijk is dat we elkaar begrijpen en gewoon de juiste informatie op de papieren zetten, zodat de mensen die het kopen eigenlijk blind het product kunnen kopen. Wat ik hoor is dat 75% van de mensen eigenlijk al op koa koopt, hè? In heel de wereld eigenlijk al. En zeker als ik onze klanten zie die in Duitsland, Engeland, waar dan ook zitten te kopen, die lopen 's ochtends niet door de bloem heen. Ja, dus die hebben gewoon een betrouwbare informatie nodig.
Make sure that your quality and grading information is perfectly correct and send a representative product photo to accompany your electronic delivery form. The delivery forms must also be firmly attached to the trolley. The presentation of your products is very important. What is specified on the delivery form must correspond exactly to what is delivered. The presentation of your products on the trolley is just as important. So, neatly tied in bunches, proper states of maturity and growers' cards on the packaging. We shall put your product in the best marketing position. Let us show you now how we do that. Via the digital trade platform Auction Pre-Sales, you can sell part of your clock supply in advance. You can offer up to 1/3 of your clock supply at Auction Pre-Sales. You set the price yourself, which often turns out to be higher than the clock price. Clock buyers use Auction Pre-Sales when they want to be certain of having a particular product.
Wij als veilingmeesters spannen ons iedere dag in om voor u de hoogste prijs voor uw producten uit de markt te halen. Ook adviseren wij u hoe u zo goed mogelijk uw producten kunt verkopen via de klok. Daarbij kijken we wat is de marktstemming, wat is de marktvraag, de wensen van uw klanten, welke producten, welke kwaliteit in welke verpakking. Wij zijn u graag van dienst. Betere marges voor onze leden en klanten, daar gaan we voor.
Well, so that was the last step in the chain we have in the PPP. The flower auction, Royal Flora Holland, is also one of the members in this public-private partnership. And one of the things that they are thinking about and working out is you saw the auction clock. This information will be added in the future also to this product which is sold on the auction clock. So what they now do is the remarks of certifications. You see if you buy a NPS A, B, C category or a sustainable product, yes or no. And with this tool, we want to approve the validation and later on also by smart sprayers, by spray robots, to add those information that's really free of biocides, pesticides, or let's say that the timeline you see with all the history that we want to add in the future also to this product, not on the clock screen, but if you have if you have the link on the information of the available products, and you can click on it and you can view the history if you wanna check it. So I'm running something out of time. So my suggestion is that I can let's open those part, and because on the view of the trader of Flora Holland, you cannot add pesticides, you cannot add other information, but you can see the dashboard with the whole timeline and the history. And I think we already had an overview of that, and you can also find it by yourself. You can click on the different tabs of grower and breeder, and then you have the whole overview of the chain if you log in as a trader. Because I think otherwise we are running really a lot out of time. But I look to you and Mireille if it's okay also for you. So then this was then the last slide of my presentation, and yeah, if there are any other questions, feel free to ask your questions now.
Thank you, Koos. So any questions? Just feel free to open your mics. It will be more lively if we can hear you. So no questions.
I just logged in as the trader myself quickly, so I also see some approved treatments. And what I find remarkable about this tool, and then I'll give the word to you, Hugo, as you put your camera on. So it's actually more than just a logging. It's really the checking of the treatments, which makes this yeah, a blockchain solution that goes one step further, if I can put it like that. So the checking of the treatment against regulations is quite interesting. Yeah, Hugo.
Yes, just a quick question for Koos. Is related basically when you have to introduce manually the information, how do you try to have some kind of checks to avoid that or mistakes or even information misintroduced with some deliberately? So what is the best strategies to cope with that?
Yeah, so that's why we split it up. As I said, now we do it on this PPP, we do it manually, but with in a few years, I think with the smart sprayers and the spray robots, you have an Internet of Things connection. You have the validation of the machine first, and then you have the validation of the using the used pesticides. And there you have to, then is coming the next step with the decentral validation, that you know that if you have a molecular fingerprint, that you all know that's about the pesticide, for example, perfume or other things. And if you have a validated spray machine, that you know that if the volume is 100, it is really 100. And that are all the guarantees which are built in by the certification organizations who approved the application, the tool, the robot, or the smart sprayer. So and by doing now it manually, that's the first step to prove if the technique works, if you have the chain really working on the right way from data perspective. And then you are building up, and you're starting with building in all the validation processes by techniques and by algorithms and by scanning tools. So on that way, we do it step by step.
Okay, yeah, it's interesting because it is so in the validation step, you always try to have a mix of something like an algorithm that can have like a redundancy mechanism combined with a manual validation for some entities or some institutions. Okay.
Yeah, you have, I think there's, you can see it in the same way as autonomic driving started. you have a few levels on that, and you start with level 1, and you wanna arrive on level 5. But even for autonomic smart sprayers or smart robots, you have the same process to follow. It's going step by step, and you have to train the technique, the algorithm, for example, for car driving, that he is detecting someone who is on the street on a bike or walking on the street, that the car has to do something, and that's a training model, and you need it on the same way for this kind of innovations.
Okay, thank you.
Thank you too. You're welcome. Lorenzo, I see your hand.
Yeah. Hi. Well, first of all, thank you, Koos, for your fantastic, amazing presentation. It's really amazing, this Flory chain example. I wonder if this system could be transferred or is exportable to other crops. So I am thinking, for example, in Almeria, in Spain, in the south of Spain, probably in this place, there is the highest concentration of greenhouses for producing tomatoes, cucumber, and other vegetables. And they are really concerned about, for example, this kind of issues like amount of pesticides, replacing forbidden pesticides, because that is changing every day or almost every day, the type and the concentration, the limits. So I had several talks with them, and growers and breeders are really concerned with this. So this is my question. So do you think that this is transportable or exportable? Is possible to transfer this technology to these growers?
Yeah, for sure. It is. And so we are working out for pesticides and all the products about a standardization to use a international standardization of the using of pesticides. The name of that product is Meij. It's in Dutch, de Milieu-indicator gewasbeschermingsmiddelen, and it's an indication tool of the use of pesticides on crops. So I think that's also our aim to and the goal to have an international part, but the tool as we have now, it can still be used also for growers in all over the world. We have 2 languages, Dutch and English, but we can also add some more languages. So even on that way, we can make it more suitable. It's the thing is that we have. I don't know how it's in your country, but over here we have the connection with a web service with CTGB, so it's a part of the government who is registering the pesticides, and it's confirming to international standards. So the only question is if they in your country using also an API, and otherwise we can do the check for the Dutch API, because in my opinion it's for the whole of Europe that they have the same conditions. So I have to check that, but for that way it's not a struggle.
No, really. So the growers complain because the limit is a nightmare for them, because the limits are changing almost every day. So at the end of the day, they have a very big mess related with what we can apply, how much we can apply, what is the delay, the time between last application and commercialization. So this is really important for them.
It would be nice to have a small experience even on that. So we are open for that. So feel free to contact us if you have some related questions to that.
Okay. Thank you, Koos. Thank you very much.
Welcome. Are there some other questions or suggestions or feedback or?
It seems there are no more questions then.
No.
Okay.
Okay,
So,
then I step out to give the floor back to you, Mireille.
okay, thank you very much for the presentation, for your
Welcome.
time. So we have ended the morning session, and the afternoon we will have Mireille again and Wassenaer in the scientific lecture that will be about developing a blockchain application for a successful use case. And this session, this scientific lecture, will be open to other participants. So I'm putting here the link so that you can access them through this link. So see you there at 1 p.m. and yeah, enjoy your lunch. Thank you. Bye-bye.
Sure. See you later.
Ciao, ciao, bye. Have a
See
nice
you.
lunch.
Bon appétit.
Thank you. Ciao. Ciao, bye.
Let's start.
Yeah, go ahead. Thank you.
Okay. All right, so welcome to this session as part of the summer school program. We are on day 2 of the 5 days. Yesterday we had, for those who were present and those who weren't present, yesterday we had an introductory day. We focused on why blockchain could be applied in the food industry. We also talked about careers in blockchain and research. And this morning we had a deep dive session into a blockchain application that was developed in a consortium of partners in an ecosystem in horticulture, and Wageningen research is part of that. So my colleague Koos presented that this morning. I provided an introduction to the application area. And for those who are new to this summer school, who've missed all of that, well, good news, you get to join this afternoon session with Lan and myself. For some of you, it's still the morning, but we're already halfway our day. Welcome. I'm not sure how much I should say about the Trust Eat project. We are working together with INL and IBM on blockchain applications in agri-food. You can find additional information about this project on trusteat.eu if you're interested. And thank you for joining in advance. So I should be sharing my screen by now. The topic of today is developing a blockchain application for a successful use case. And we'll also discuss what we mean by a use case. First, let's do the introductions. Let me start, Lan, and I'll hand it over to you.
Hi, good afternoon. I am from Wassenaer. Yes, I already started. So
Go ahead.
I'm a colleague of Mireille. I work on innovation, risk and information management in agri-food. I would like to call myself economist, but not usual ones. That's it for now.
Okay. Yeah, my name is Mireille van Hilten. I'm a researcher at Wageningen Economic Research. I work in a slightly different group than Lan. We work on data and information management, and I'm involved in several types of projects, not only blockchain projects, but also other technology types that have to do with the digital transformation of our sector, which is agri-food. And at Wageningen University, we deal with many different types of research themes. And I think, Lan and I are mostly involved in the bottom one, which is data-driven and high-tech, if you look at the slide. That doesn't mean that it's only about that. Obviously, it's just a way to work on sustainability goals. So even for blockchain, it's not about just the technology, but what we can do with it, right?
Sure. Well, we want to use data and technology to contribute to the other themes, of course.
Exactly. So the summer school program is about these 3 application areas. And I see our colleague Nuria has also joined. So we've started, Nuria. If there's anything you want to add, just hop in.
Yeah, just sorry that I was not able to enter and welcome everyone, especially if there are new participants to our Trusted Summer School and the scientific lectures.
Yeah, thank you. So our project and also the summer school is built around these three application areas, or sorry, layers. And today is about the application area. You can also see which organization is involved more in one or two of the layers here. So we really work a lot on this area where we apply technology. So that's the top layer, and that's what we're talking about today. But also the bottom layer, the digital layer, how we can actually make sure that we use data in agri-food in relation to IoT, Internet of Things. But we really collaborate a lot in this project with IBM, our colleagues at INL, who are involved in all three layers. So I guess during the project, we're finding out how we can make all of these layers come together. And yeah, throughout the week, we'll cover those layers. So the program of today, we've got three main topics, and we can finalize with some discussions or questions, but also feel free to ask your questions during the session. If you feel anything is unclear, just feel free to unmute your mic or drop a message in the chat. So the first topic is all about a use case, mostly related to the blockchain use cases. The second topic is more about how to apply blockchain from a technology perspective, but also the economics of information and how to implement blockchain. And then the third one is a little bit more general about an ICT development track. So we hope to inform you very well of everything that can happen in our application layer today. And then the first slide is about what it is, a use case, and I'll hand it over to Lan.
Yes, I'm happy to talk with you about use case. Use case is a term that is very often used in software industry, but also in blockchain applications. But it's good to notice that if you want to do research about blockchain use case, you will often note different spelling of it, and it can have consequences where you want to search for examples. But anyway, it's not just a spelling, it's also very different. There are also many different interpretations what people think of a use case. So some people think of a use case as a potential scenario, a situation in which a technology or solution could be applied. Other people refer to a use case as really fully developed, an example. So it's good to keep in mind when we talk about blockchain use case. And furthermore, I think to consider a blockchain use case is very important to see in what situation it is applied and what kind of problems it aims to solve. And of course, what are the technological configurations, what technological choices are made. And most importantly, it's also about ecosystem. I would like to emphasize that ecosystem is a term that is used in social sciences or in software industry in a very different way, of course, from our natural science counterparts. So it's not about ecosystem as consisting of water ecosystem or mountain ecosystem. It's really referring to the whole system or network of actors, stakeholders, people who work together, but of course with some interactions that can commonly be described as a business model or a governance model. So ecosystem is very important for any technological solution to have impact, because you cannot put technology somewhere without the collaboration or use by different stakeholders. But of course, these are theoretical considerations. I think along the way we'll show some examples of use cases. It will become clear what we meant by developing a successful use case. Next slide. By the way, if you have any questions, just feel free to raise your hand or just interrupt. When we consider developing a successful use case, it's very important, as I just mentioned, to have a working business ecosystem. And to zoom in further, it's good to know what are the actors who are active or relevant in a blockchain ecosystem. And then, well, it's not enough sufficient to identify what actors are relevant. You have to engage them so that you can really have the solution or the technology to be put to work. And when we study blockchain use cases, well, of course, it's a common user method, it's a case study. What we notice is that for every use case, if you want to study the use cases, you need to understand that every use case consists of, well, it depends on how you define it, but at least 4 aspects that are important to distinguish one use case from the other. The first one is the problem or the opportunities that are being addressed in the use case. For example, some blockchain use cases are really about solving the financing problem, or others about traceability. So you have very different types of use cases. And then in every use case, blockchain technology is, of course, it's a very generic term. It can be applied very differently depending on which technological platform or other infrastructure or specific technological choices. You can have very different configurations of blockchain technology. And then related to the first one is different use cases often result to or strive for different business benefits in terms of better efficiency or better profits or other business benefits. I wasn't done, but could you revert to the previous slide?
Sorry, that's a mistake.
Oh, don't worry. And in addition to business benefits, very often discussed aspect is the governance benefits, because use blockchain, you can make different processes more transparent to avoid, for example, corruption or other commonly known business governance problems. And to understand every use case, you need to use some lenses from economic research or economic thinking, and also theories or methods in understanding ecosystems, which we'll come back to later. Next one. So given the definitions or understanding what use cases are, we can plot use cases in a sort of a landscape through different lenses. You can look at different dimensions. So this is one example in which in our research we plot different blockchain use cases based on the main recipient or the main owner of the problem or the benefits, and also the sort of problem that have been addressed. So if you see from the horizontal side, you see many use cases are about people or the profit aspect in sustainability. So there you have use cases such as AgriWallet or a Beef Ledger, and some of the use cases are motivated for the benefit to improve the benefits or income of farmers. So we call it farmer-centric. The other ones were more driven by supply chain management. For example, beef chain or Walmart use cases. So they intend to apply blockchain to make supply chain more efficient or transparent or fair. There are other type of use cases. They are focused on informing consumers about various aspects of the supply chain. For example, whether a product from a supply chain, a certain commodity chain, is it fair, or was it produced in a sustainable way, and what kind of certificates it had. And there you see use cases such as fair food or right origins. So these are use cases more devoted to improving the well-being of people or different businesses. You also have use cases that are more motivated by environmental concerns. So we group them in a under layer in the planet aspects. So you have a very interesting use case as Nori, so intends to make carbon credits traceable and tradable, or other use cases such as tree coin, to enable you to use blockchain to trace, register all the trees that are planted in order to offset carbon emission. So here you have more, I hope, more tangible examples of use cases. Of course, for every use case, you see that they have their own problems, they have their own technological choices, and they also have their own ecosystem. And those are the aspects which we use to inventorize or classify them. Next one. I believe this example you saw this morning, so I'm not going to repeat. This is an example we developed ourselves to address the problem in the horticulture supply chain, which is currently not very transparent and also not always traceable when it comes to detailed use of agrochemicals or other inputs. And so we are developing the use case to improve that situation so that certain use of agrochemicals or plant production products can be traced throughout the whole supply chain. Next one. Oh, I thought I could give this back to you, but I'm happy to introduce a bit about ecosystem. As I mentioned before, ecosystem is a concept used in social sciences or software industry to describe the collection of stakeholders, actors that interact with each other around a certain theme or a certain problem or a certain topic. And in the case of a blockchain, we can make sort of a generic business ecosystem around the blockchain. So you see you have technology providers who provide really the services or infrastructure for running all kinds of blockchain applications. Then you have users, which can be you and I or other citizens or other business companies. But of course, we can all use blockchain in different ways. But in a generic description, we call this blockchain users, meaning that they are not actively developing or contributing to the technology itself, but rather more interested in using the technology for all kinds of purposes. And what there are other more actors or groups of actors fulfilling different roles in such an ecosystem. But altogether, this is a way of coordinating economic or social activities in which information and values need to be exchanged or traced, or you need to keep a record of. So together it forms a sort of social ecosystem. Next one. So I think for, of course, system or ecosystem is a very broad concept, and it depending on the situation or the problem, it's very important to set the boundary and the key elements of each ecosystem. But for developing a use case, an important concept is a minimum viable ecosystem. This means that you need to identify what are the minimum or minimal group or collection of actors to fulfill the essential roles in which the ecosystem could function well. And this is because that for every blockchain application, you cannot apply it on your own. Blockchain is essentially a bookkeeping system, if I may call it, in a group, in a network with different actors. So because of this, you cannot apply blockchain in any single company or any by any single actor, because you always need interactions of different actors or different organizations. That is why that ecosystem has such a central role or place in our blockchain applications. And to understand, to identify the minimum viable ecosystem, we need to understand what are the key value propositions of the actors of the main developers or users of the blockchain application, and what are the factors that are driving or pushing the application. And most importantly, you also need stakeholders that not only want to be informed, but really like to be committed with time or resources to have the application working. So these three are very important to develop a meaningful, a viable ecosystem that really show the value of blockchain. The next one.
Yeah, I can take the next one. So I think it's maybe a little bit a collection of what Lan talked about up until now. So we have this ecosystem, which is a minimal viable ecosystem. What is the minimum set of partners, if you want, that you need in a project when you start working on a blockchain application? And then it can be a quite large ecosystem as well throughout time. And we found a way to kind of put them either in the inner circle, making them the internal stakeholders. That's everybody that is really part of the core project, such as an organization that initiated the blockchain project. So that's maybe the organization that also ends up paying for it, not in all cases, but that funds the project, or that maybe feels the most pain points in the current situation. It's not always the case, so it really depends. So if a driver is, for example, a large retailer that is really focused on creating transparency for consumers with a blockchain solution, probably the retailer is also paying for it, right? And that's an example of a stakeholder that is inside the inner circle, the yellow circle on the screen. But also any partner working directly on the solution, on the software, if you want, or on the technology, is also in the inner circle. So the minimum set maybe is in the inner circle, but then we have the indirect stakeholders around that, the middle layer. They're optional, but in some projects, they can be quite an important stakeholder. So for example, if it's a food value chain that has to do with certification of, I always use the example of organic food. I apologize for that, but it can also be fair trade or pesticide-free flours. Then that certifying organization can also be in the indirect stakeholders circle. And then we have the external stakeholders in the outer blue layer. Those are stakeholders that do not directly influence what you're doing in the project or the solution, but do have a stake in what you're building. For example, regulators, or you could consider the consumer as part of an external stakeholder, but it depends. If the consumer opinion is really driving the project, you could involve them and make them come closer to your inner circle, if you like. So that's just a way to look at the ecosystem. So who is involved? And then in addition to what Lan already showed you, these are all examples of key actors that can play a role in a blockchain ecosystem. So maybe I'll just highlight a few of them. So we could work, for example, the fourth row with blockchain as a service provider. So their blockchain solution would be provided in the cloud, so you won't have to install any servers or any software. Government, regulators, law enforcement, you could have a hardware provider, investors. You could work with smallholder farms or consumers. If it has to do with tokens or crypto coins, you would also need wallet providers. So the list can get quite long, as you can see. And I think the idea is always to start small and then go bigger from there. So that you need really to think about the minimum set of stakeholders that you need in the blockchain project. And then this is not specifically blockchain, but in general, if you're working on a technology project, once you know exactly who the stakeholders are, and you thought about who are the internal, indirect, and external stakeholders, how do you involve them? It's really maybe very straightforward to bring this up, but during the project, it's always difficult to make sure that you involve everybody in the right way. So the further outside in the circle the more indirect the stakeholder, probably the less frequent you'll need to involve them. But even that is dangerous to put it like that, because again, if your consumer is very important, yeah, you may want to do some testing with the consumer, and that means you need to do more than keeping them involved and informed. You need to really involve them extensively. So be sure to rank your stakeholder for importance and the influence they have on your project. So the example of a Flory chain this morning that talks about regulations for plant protection products for the horticulture sector. Well, as soon as regulations change, the impact is quite high, or the influence. So you probably need to check in every once in a while to see if there's any changes or any new regulations coming up, right? So you should check the sphere of influence regularly. And the more important your stakeholder, yeah, you really need to make sure that you address their concerns. So that's what we call stakeholder involvement. And it's also a project management skill, I think. But it couldn't hurt if in the beginning of your project, you really draw this map out and really think about all the organizations that are involved and how to include them. I think this is for you again, Lon.
Yes, thank you very much. I think it's a good summary of what we just discussed about ecosystem, and also perhaps a note of warning in developing ecosystem. Is very easy to get distracted because you want to involve everybody, and sometimes you forget to identify the most essential viable ecosystems. I think that's something that's commonly an explanation for many project failures because of the enormous coordination efforts needed and having a large diverse group to work together.
Mm-hmm.
That's a side note. I thought, what at least we thought, to understand a successful blockchain application, it also would help to understand a bit the theoretical background behind a blockchain application. And I thought three lines of thinking are relevant here. First of all, is to have a basic understanding of the technology stack. It sounds a very abstract term, but it's just what does the technology blockchain consist of? And then to understand the application, the economic or governance benefits, I think a useful angle to understand that is economics of information. And the third one is to look at blockchain technology or application from the process of implementation. There, I think, are also where different considerations come together. Next one. To understand the technology stack, I think I perhaps would help to make a metaphor, like our life when we use certain technology. Usually, we only see the tip of a iceberg. We only use the part that are visible and tangible, while underneath the surface, there are often many other layers of technological infrastructure that we usually do not see or do not even know that existed. The same is also with blockchain applications. For most users, especially blockchain users of financial applications, when you only use a blockchain wallet to trade cryptocurrencies, you may wonder what does it differ from other financial products? So that has to do with this stacked different layers of the technology for which we only see the upper parts because we are usually as a non-blockchain developer operating on the level of the users. So we struggle with our problems. We strive for our aspirations. We do not often bother to understand what goes beneath any applications, any tools we use. But it's good to know that because when we do want to develop a blockchain application, we may need to communicate or interact with people who develop the services that are for the functioning of the other layers than only the interface. And there are different ways to understand this technology stack. I think one more commonly used one is the Open System Interface model, the OSI model, that if you Google, you can find it. about how we exchange information and data through the internet. So when we send email to each other, we usually only are operating on the application layer. We use Outlook or other software system. We send email, the other recipient would get it. But underneath this application layer, you can understand there will be other technical layers to convert what we input in our apparatus, our smartphones, and translate it into other data layer. Eventually, it will all become electronic signals that can be transmitted through cables or other physical medium. So the same, so if you translate this general internet interaction to a technology stack of blockchain, then you see at different layer, you have different technological components. So for business developers or for users, you may not need to understand, but for people who need to finance projects, many of the choices beneath the interface level may matter a lot. For example, if you choose to develop your own platform, or you choose to develop a application on an existing platform, there may be different implications for the cost and timeline of the application. So I think depending on what level you intend to perform research or develop the application, it's good to know what kind of choices there are. And we have written some reports. I think if you look into it, you can find more background information. For now, it's just good to know that there are different layers of the technology, and blockchain can influence different layers in different ways. Next one. So here's an example of different technological options that are that can be chosen, or you can, for developers. This is one way of visualizing it on the different layers. So you see there are technical standards or specifications involved in choosing different applications. A notable example is that some applications would involve the use of digital currency, others not. So there you already need to make a choice. And when you do want to have the functionality of digital currencies, you may consider different sort of platforms than others. So, but there are well-known resources or other web-based information center where you can find such overview or a list of potential options. And so there was a more overview of the technology stack, just to give you an idea of the choices that may be involved when you develop a blockchain application, depending on what type of problem, what type of opportunities you want to use for blockchain for. But then behind these applications, I think I just mentioned the economics of information helps to make choices. And before that, of course, it's good to make a little conceptual distinction of what this definition of what information is. I think not only in science, but also in practical application, a definition of a term is never a trivial thing. The same goes with information. For many people, information is almost synonymous to data, which of course then you then you already miss a lot of steps that are need to be taken before you can get information from data. And furthermore, I think it's not enough to get a summary or average or other information from basic data as record or as basic measurements. It is important to derive knowledge from information, and that can be further applied in other domain or other fields. And with knowledge, it's also not enough, because you also need to have the right wisdom to apply knowledge, to choose the right problem or to find the right opportunity. But anyway, so information is important. First of all, it makes data useful for knowledge creation. and but you do need wisdom and knowledge to decide or to identify what information you would need and where you can find the relevant data. So that it doesn't go one direction. It's generally in practice, it goes always both ways. You need wisdom to look for the data where it lies, and you also need data to create the information and knowledge which will eventually result in hopefully wisdom. So datafication is finding wisdom. They are a very interactive, iterative process. Because this interaction, because information has such impact on decisions or the type of wisdom we have, you see why data will be important, because if we don't have the right data, we cannot have right information or knowledge, and then we cannot make informed decisions. And of course, decisions will eventually decide what applications will be chosen, how the application will work out. So it's just a little bit one, not to promote the field of information technology, but it's just to show that why data is so important. It is not just a hype. It is really very essential for the functioning of our society from both technological and social point of view.
Lon, can I add or ask you something? So
Sure.
in addition, so as far as decision making goes, we often have like a research question or a question or a problem to start, for example, a blockchain application, and then we get the data. But isn't it also the happening that it's technology driven and there's so much data that we can now ask the questions on, tell me what I don't know, because there's the data and we have the algorithm. So, and how does that relate to this triangle?
Yeah, I think that's an excellent question, because this pyramid gives a false impression that it goes one direction. That's why I emphasize that it goes both ways. So with sufficient data, if you apply some sort of data mining, you may it may reveal some patterns or reveal some hiatus in knowledge that can help us to find new research questions. So that is part of the pure unsupervised machine learning part is about. I may introduce a bit more tomorrow. So I hope that addressed your question. So it goes both ways. Sometimes you start from a question, you look for the data and try to find the answers. Sometimes the data reveals the questions that still need to be answered.
And predicts what will happen in the future.
Yes. Or gives you indications, so there are two ways. One way is you let data speak. Other way is sometimes data speak for them by itself.
Mm-hmm. Yeah, that makes sense. Thank you. I shall put up the next slide.
I think the next slide is about economics of information still is, so first of all, information helps us to have the wisdom or the knowledge to make decisions, which will eventually have tangible impact. But the information itself is also very important, because in our society, nobody is living alone or can live alone on his own. We all need to make arrangements with each other, because in the society or in any ecosystem, we have interactions. To have a good society, a well-functioning society, you need to make a lot of arrangements, and loosely in economic terms, we call this institutions. So they can take very different forms. Institutions are different from organizations, but it's generally a set of agreements or understanding between actors, how they would collaborate or interact with each other. So we have markets, have government, you have contracts or norms, even cultural traditions. Those are all institutions, ranging from informal to formal ones. So we need institutions to make our society working, because we need to match supply and with demand. It's not enough for consumers who want things. You also need to find producers to produce the goods, and likewise, if a producer produces things, would need to find consumers or buyers to purchase the products. And to make the two, demand and supply, match each other, you need information about the quantity, quality, and delivery terms. So that is a very important role of institutions. And for an institution to function, you need information about all kinds of things, about physical supply and demand, but also about more intangible quality requirements. And to understand the working of institutions, is like, of course, you can define any set of agreements or arrangements as institution, but how do we choose the good ones, efficient ones, from less efficient ones? So how do we make or choose, design different institutions? So here it is important to start from what kind of collective goals or benefits you would like to achieve with the institution. So in, for example, a government institution, it is set up for a country because the country needs to be protected, needs to feed its inhabitants, needs to have safe traffic. So there you have the benefits, and it's then together with all the citizens, you make an arrangement that the government has authority to make the rules. So there are the benefits. You have self-sovereign country. Of course, you can also have an institution of how in a supply chain you would different actors would work together. There you can imagine you need to have food standards, you need to have specifications of different products, and also under what conditions products should be produced or transported, and how can a consumer pay the producers, so through what kind of currency. So those are the institutions that would be needed to have a well-functioning supply chain. And to choose different types of institution, you need to, as economists, evaluate their performance based on two things. First of all, does it help to achieve the goal you want? So is the current institution sufficient to ensure that a producer can deliver his goods and get paid, and consumer can receive the goods he ordered and in the right quality? And so if that works, so it's a useful institution. And on the other hand, institution it can exist in different forms. Some institutions, if they can involve a lot of cost for all the parties involved, we call it an institution that creates a lot of transaction costs. Of course, if that's if an institution creates sort of arrangements involve a lot of transaction costs, it's not efficient. Eventually, it will be dissolved or reorganized. So that's one way to look at it. But how can institutions influence transaction costs or whether it achieve the goals? So they do this by efficiently by using effective information. For example, if an institution can provide reliable information, reliable and timely information on the supply and demand, it will be very efficient, so that supplier knows exactly where to deliver and what he will be paid, and so the transaction can take place easily and efficiently. So then you can imagine if in a institution, in a collective institutions, if information, the quality of information and the availability of information will be very good, then you have very efficient and efficiently functioning ecosystem, and you have better organization of supply and demand. So I think this is the way to look at economics of information. So when you have reliable, timely, trustworthy information, different individuals can better collaborate or coordinate their activities, because information on supply and demand is there, and they can easily match supply and demand. Then you can also avoid unnecessary waste or high transaction costs, because people have to search, negotiate, and with a lot of uncertainties. So this also emphasizes, from an economic point of view, how important it is to have efficient and reliable information flows. Next one. And so that also explains why there's always been effort by different actors to try to improve the way information is exchanged or shared between any society or supply chain or other network. Traditionally, I put here an example. Traditionally, supply chains are organized in a rather linear way. So, a farmer produce, he would deliver to the next to the trade or to organization that purchases, and information goes along, and the information will be passed on further to the next buyer or to the transporter. So each person usually keeps or party keeps its own record in its own formats. So after a few steps, information will be very different from the initial ones, because people along the way, along the chain, different parties may add his own information to the original information or transform it. So if I as a farmer deliver a ton of potatoes to the chip producer, a chip producer may record it differently. For him, it's perhaps more interesting to record things in tons and not as in kilos delivered of potatoes, but rather in the content of starch. So see, and to the next stage, if when it's delivered to a chip to a supermarket, the supermarket may not be interested in kilos of potatoes or kilos of starch, but may be more interested in whether it's how much calorie is in it and how much price it is in it and where it comes from. So you see, in different stage, information is added or transformed or deleted, because of course the farmer will not send all the information he has to his buyer, because he doesn't want him to know his trade secret. Similarly, supermarket retail knows more about products, but he would also not like to share, for example, the purchase cost with consumers. So in a supply chain or in other network, there are a lot of considerations not to have the same information shared by everyone. So you end up in a very complex and not transparent supply chain. And this is why you need people or organizations, arrangements to check, to keep accounts, and to authorize people to review or read information. And also you need parties to authenticate, to verify whether what is put on the label corresponds to reality, and you have other people to verify that and validate all kinds of claims. And so all these activities are fulfilled by different parties, but essentially they are all producers of information on supply, on demand, on quality, on value, and that enable a producer to deliver, a consumer to buy. And so this system, as it's currently organized, has many problems. For example, lack of transparency, the existence of fraud, because fake information or unjustified claims can be made. And how can we make this better? So one way to make this better is that instead of transmitting information linearly, let everybody add or transform the information. You make a collective agreements, so you have a collective validation or verification rules, so that in the end, and also it's not linear, but can have more in a networked validation mechanisms, so that any information that enters in the system will remain intact, and eventually people will have at least identical information that is important for coordinating or collaborating with each other. So I visualize these two situations. The first one is more like the game we all play as a child, or in other situation called Chinese whisper. So if I whisper something to you and you whisper to the next person, very often the final recipient hears a very different story from the original version. The same goes also in the supply chain. So that the final recipient of we as consumer will receive a label with information that's not exactly the same a farmer or even a seed supplier provided in the beginning. But we all share the same interest along the supply chain, is that we want to know whether food is safe, whether it's really from Italy or Greece as it claims. So authenticity and safety, and those are the aspects on which we would like to have same reliable information. And there it's the better way is not to use in a traditional linear way, but to share the information in a more distributed and a networked way, so that information can be validated or verified or checked by different parties to ensure we have we have the same identical information. So I think the importance or the contribution of blockchain to many societal problems are covered from these considerations, but are mostly can be traced back to the economics of information, how information influences different physical production and consumption processes. And I think that is something important to keep in mind when we look at blockchain applications. Thank you. And the last one is about blockchain implementation. Theoretically, I think it's built further upon the economics of information, so and state ecosystem considerations. If you want to have a blockchain implemented, you need to consider what exactly what are the economics of the information that it's with this blockchain technology it brings to different actors, but you also need to make sure that different actors understand, accept, and willing to contribute to this collective information sharing institution. So that process is, you do not have a blueprint to make a blockchain implementation normally, because you need a lot of interactions and discussions to come to the same understanding of the type of information different people want to share with each other, also the type of conditions under which information should be shared. So any blockchain implementation is always a multi-actor process, and also not only actors in the problem area, even among technical or other actors, you also need to agree with each other what type of technological choices should be chosen, or what type of agreement should be made in order to have desired outcome. And I made a list here. So theoretically, if you would like to have blockchain implementation, you should really check that the problem or opportunities match the potential of blockchain as we discussed before. So do you want to share information in a way that blockchain enables? And do the stakeholders recognize or accept those the changes in a way they share information with each other? And whether basic infrastructure is there. By basic infrastructure, I meant also the things that we do not see underneath any application. So you have the digital infrastructure in terms of internet connection, um, smart devices. So those are the hard infrastructure, but also soft infrastructure. So have different stakeholders agreed on sharing data in a way. Otherwise, if we have a software designer think of different data to be shared, but in reality, stakeholders do not want to share them, then you do not have a successful, good blockchain application. So that is why the governance models are part of the soft infrastructure of any blockchain application. And So these are more soft elements in blockchain application, and more technical aspects. I think they also very often follow from the social or economic considerations, because they often certain type of technological choices actually support different economic considerations. And not to forget is that you need to not only identify the ecosystem, you need to really develop and curate and make sure that it continue, because any ecosystem is a living thing. People change, stakeholders in the ecosystem may change their strategy, may have new objectives, or may new director, they will change their strategy. So the ecosystem is constantly developing, and that has very important impact on blockchain application. So it is important to keep monitoring, and when it's possible, also as a curating, meaning to help facilitate the desired development or interactions in the ecosystem. And standardization is one that is often forgotten, because when people start to share information, or to define digitalized processes, they often use their own ways. And so once a specific data set is made, and you use your own columns or rows or names of the variables, if you don't use a standard that's recognizable by other organizations, it's not easy to share the information then. So it's good to check this beforehand when you start to register information, whether there are already similar standards or codes that can be used to develop the data or protocols or agreements. So standardization helps to implement blockchain, because it makes information sharing or reuse of information easier.
Yeah, so we have this in between slide to check if what we've said so far makes sense. There are a couple of new items in there actually. So if you are very familiar with blockchain, you may score some points. Well, it's not for points, it's just for fun. But so do you remember how many layers are there in the blockchain technology stack as Lon presented them? Because you'll find different models all over the internet, but try to figure it out. How many were there?
This is just to check whether you have listened.
How many? 5 or? It's not about the amount of layers, of course. No, there were 7 layers. So I guess the main message was it's not just the application layer. There's a lot of layers beneath that, and everything needs to connect. So which one was, I already gave away one then. Which layer was at the bottom and which one is at the top? So the top one is application layer. And what's the bottom layer?
Physical.
Physical. Well, that's the part of the 3 layers, but yeah, you're right. Even in the 7 layers stack, you paid attention. Very well done. Well, and this one, I don't think we really, because it comes from another session, actually, we really didn't go into that this afternoon, but can you imagine which verticals mostly apply blockchain technology? So we're in agri-food, but which ones are common to apply blockchain? Anybody want to have a go? What's the most common blockchain example that everybody knows?
Bitcoins.
Yeah, Bitcoins, right? So finance, but also logistics and regular supply chain are
also marketplaces.
Marketplaces?
Yeah.
Yeah, exchange. Yeah, of course.
Exchange, peer-to-peer transactions, whatever, using blockchain.
Yeah, all sorts of coins or tokens. Yeah, definitely. So that came up in one of the previous sessions. I think it was yesterday. So in agri-food, we're not the front runner as of yet. We can never become the front runner, but we can at least try to catch up a little bit on the finance and the verticals that are running in front of us. Who knows who the founder is of blockchain technology?
IBM.
IBM?
No.
Or
No,
what
I think it was a Japanese or something Chinese, whatever. It's a guy that creates the first block. I mean the first one.
Yeah, it has to do with the Bitcoin. Lorenzo,
Yeah.
you turned your camera on. Do you want to have a go?
Yes, I agree with Joseph. Was a Japanese guy.
Yeah,
I don't
it's
remember the name.
Sajoshi Nakamoto, and actually his identity is unknown because he seems to have disappeared. So we're all here thanks to him. Yeah, so that was just a little bit of a recap. I'm looking at the time. We didn't really calculate any breaks. Should we just continue, or do we want to have a quick coffee break? No,
We
yeah.
can do a quick one if you want, 5 minutes.
Just,
or
okay, 5 minutes.
as
Just
you consider that you have time later on till 2:30.
we have another half hour, right?
Yeah.
Yeah. Okay. Let's grab a coffee and a tea, and we'll be back in about 5 minutes.
Okay.
Okay.
See you then.
See you.
Sure.
Hi.
Hey.
Docent.
Ja, jij ook. Nou, gaat lekker toch?
Ik kan een lesmodule ontwikkelen.
Ja, ga gewoon een MOOC maken.
We could make this a quiz.
Hello. Yes, we can. We can.
Yeah. Would you like to turn this into a MOOC?
Yeah.
So I think everybody's back or almost back. So let's continue. So far we've talked about the economics of information. We've talked about the ecosystem and all the stakeholders involved. The next 2 slides are a little bit more about research and research methods. This is a recap of one of the previous sessions before we did the summer school. But if we're talking about blockchain in the research context, we also tend to approach it like any other information system. It is a little different. It's more complex because it's not an information system for one organization specifically. It's the entire chain or ecosystem. But we do want to start with the basics of an information system. So it's where economics and technology and organization come together. So in this Venn diagram, the information system sits right in the middle of it. And it's important to realize it's not only the technology, but very much so the process and the people. And a process, we often speak about business processes, but of course, a supply chain process. The purpose of a supply chain process is to provide food. In the case of agri-food, at least. So if at the end of the process of supply chain, we have the outcome of food, healthy food, verified food, then the whole process is aiming for that. Of course, a process is not just a few steps. There are people working in each and every step and sub-steps of a process. And they all touch technology. If we go back 30, 40 years, technology, computer technology was mainly what we call office aiding, right? So it was a more automation of generic steps that are that apply for all sectors. So what we now use in Microsoft Office, that's what IT was. But IT is inside each process within each vertical. And digital transformation is everywhere now. So again, people, technology, and process, where those come together, that's where the information system is built. And that's what we're researching. And our colleagues at the university research it more from a fundamental perspective. And we are really interested in how it's applied in real life scenarios. So we hope to give you also an idea of what we see out there in agri-food at the moment. Some use cases are more successful, some use cases are less successful, but this is behind it, right? So that's what we're researching. And one of the methods that's often used in research for information systems, information technology, is the model that was created by Hefner. And it's all about practical relevance because, yeah, it's about, is it a real organizational problem? Lan also spoke about that earlier. I'll come back to that a little bit in one of the next slides. And does it work in practice? We can have a great technology, but is it being used? And is it being used effectively? And then when we're doing research, it's all about academic rigor also, especially because if we're looking at applied situations and practices in real life, it should be based on solid building blocks, and also the knowledge that is generated and constructed based on real life scenarios that needs to go back to the research ecosystem, if you want to reuse the word ecosystem. So if you look at the model, we have the people, the organizations, and the technology. So we see the same as the previous slide, right? Where we saw people, process, and technology. That's where the business needs come from. Then if we look at information system research, there's the development of new systems, and there's also the justification of, are these systems being used, or in what context are these being used? Are they being used successfully? And that's where, case study, we don't speak about case studies for no reason. It's also a scientific method to research these real life scenarios. So you can either do a single case study and go into depth and do many interviews, but you can also do a multiple case study, which was what we often do, and then try to have a nice geographical spread, look at are these results going to be representative for the entire industry or the entire field. So that's what we do. And then, the knowledge base on the right side, what comes out of the research will go back into the knowledge base. So that's the model that can be used of Hefner. There are other models out there as well. It's not the only one, but it's at least one of that we're familiar with. So now moving on to the third topic. I think there'll be a little bit of repetition maybe compared to the previous topics, but from a different perspective. So we're really going to talk about how do you organize this from a project perspective. So now we have seen the blockchain applications. So now let's start. Let's start a blockchain project. Let's build a use case. And where do you start? Yeah, you start with the problem analysis. Then you go through the development process. And then you end up with what we call a proof of concept or a prototype or different testing systems. So let's go through those topics. So if you go back to the problem analysis, it doesn't always have to be a problem, right? Where a blockchain use case starts. It can also be an opportunity, but often it is a problem. So it's either lack of information. Let me look at my own slide for guidance. Lack of information can be seen as a bottleneck. So one of the first items there. So if you consider a supply chain like a process, as soon as there is not the information available that is necessary for the next decision in the process step, yeah, that can be seen as a bottleneck. So often in blockchain use cases, it's limited data sharing in the ecosystem. And why is that so common? Because it's just very difficult to share information beyond the borders of one organization. And Lan, if you want to chip in, then please do.
Yeah, it depends. I think essentially it's about the problem in exchanging information or values. So in our application in supply chains is mainly about exchanging information, but in the case of cryptocurrencies, the original motivation was to avoid the double spending problem. So if if you don't have different bookkeeping systems, then one person can spend the money twice before it is called. So.
Yeah, and maybe that's the second one, right? So it's data redundancy. Sometimes we have the data stored in different systems, and which one is the correct? It's the case of double spending. But anyway, it's a little so that it's either a bottleneck, something that's not working, or it can be a waste. Waste comes from the thought process of lean processes, and generating waste. We can speak about 7 to 8 different types of waste that can be generated in, let's say, a food supply chain. It can be over transportation, overproduction. Waste can be really literally waste, as in food that we throw away. But it can also be waste in the sense of information waste. So that's why I wrote down data redundancy. If you speak about data transport, so data exchange between organizations, as soon as you resend the same Excel file, if you want to make it really simple, it's data redundancy, or if it's inside the systems, making having to do human rework is also a waste. So if you have to do things twice. So that can be, those can be reasons to start, that can be at the basis of the problem. And then it can also be an opportunity for optimization, which can also be a problem behind that. So if we have a lot of human data entry, which is still very, very, very common, that can lead to errors. It can also lead to an increased lead time, and lead time means waiting time, and waiting time means less value for the end customer or for the operator in the food supply chain. So those are just 3 ways how you can look at the opportunities for improving a process. And then, of course, we have all the very long list of sustainability as a problem or a reason to start a blockchain project. So food waste and fraud, but also very many environmental or circularity aspects. So we kept these very brief here because we speak about them all the time. But and then another important item, I think, for when we try to analyze the problem is who is the owner of the problem. And the question that I always like to ask when starting a project related to information technology is this actually the problem? So the initiator of a blockchain project may think that he's solving a certain problem, but you really need to be very, very sharp on the actual problem behind it. So it doesn't hurt to ask a lot of questions in your initial conversations when you start a use case, and try to uncover some of these issues and make sure that you're addressing the right problem, because ICT projects and I guess so also blockchain projects, they can fail. They're complex, and a lot of them do fail. And it can be in this first step that it goes wrong. So talk to the problem owner, make sure that you understand the actual day-to-day issues in the current supply chain or in the current ecosystem. And then whether or not blockchain is the solution is a question to ask, even if the problem owner thinks he needs blockchain. And then, there can be many reasons to experience a problem when you speak to a problem owner or the initiator. But it's often, I think, having to be compliant to regulations or wanting consumer transparency. So these are just 2, but I think they're very common. So there's a lot more to say about problem analysis and the ways you can do that. And I did a lot of that with my Lean and Six Sigma background. So you can really deep dive into a problem and to analyze it further. There are all sorts of ways to visualize that. And I'll leave it at that. So once you understand what the problem is, and it's also on this slide, right, where you see the not so happy face, you really need to understand the current situation. Before that, and I tried to visualize it in this slide, but before you can go to a blockchain solution, there's always a phase of ideation. So what issues are you trying to solve, and what's also the future scenario. It's not always about the problems, but you need both. You need full understanding of the problem, and you also need a horizon or maybe more horizons that you can work towards. So ideas are important too. The stakeholder engagement is also on this slide. So it's really part of the entire development process. An important one is the selection. So Lan already mentioned that. You need to select the blockchain platform. You need to think about the infrastructure. Who are the application providers, and are you going to work with a consulting services organization? So basically this means which IT partners do you need, or are you going to develop it yourself? And for that also there are many ways you can first draw up which factors are very important in this selection. So obviously cost is an important factor that determines your decision, who you're going to work with, but also the platform itself should really meet the needs. So depending on your problem analysis, and also it could be experience for IT partners, etc. So there are models to work through this as well. And the design. So as soon as you can start working on an initial design with these IT partners with all the direct stakeholders, that's a good idea, because it can really provide clarity on the final result of your blockchain application. And the most important thing, I think, is that you have to realize which data sources need to be connected. Where does the data come from? What is essential data? And the standards that Lan spoke about. So if we're talking about a food value chain that grows tomatoes and sells tomatoes, even the word tomato, which we think is the same in all systems in the world, it's not. It's really differently allocated in each and every system. So the more that the standards are followed, the better. And these standards are available. So I think these are the items that come back while you are developing, except for the governance models that Lan mentioned. They're not in here, but very, very important as well. And on the left, I kind of imagined it like an application on a smartphone, but who are the end users? It's a step that's very often forgotten, and testing it with end users throughout the project is also very, very important. And I'll come back, not in the next slide, but in a couple of slides down. The most tangible results of this project are the first versions of what you're building. So let's call it a prototype for now. And you can test with prototypes with users. Okay, no questions, I think.
No.
Okay. So, and underneath all of that, those are things you have to do, the what, and this is the how. So how do you do that? Those of you who are familiar with ICT projects, it's probably not very new, but you can take your pick out of many different ways to develop an IT solution. They're actually at the bottom. So we have waterfall, lean thinking, agile, and DevOps. Those are only 4 of the many, many different ways that you can develop software, let's say. Software or even hardware or a solution, including IoT technology. So they all have the same elements. They're all staged. So it's a phased approach to development. You don't just start building, first you design. And before you design, you understand what the problem is. And testing, you can either do it once you have a first version, or you can start testing when you have your first sketch. It can literally be a sketch with a piece of paper. So that depends. So what are the stages? Is it iterative? So do you loop back to previous stages, or do you just, well, the most traditional way of doing this is actually waterfall. So waterfall means you finish the design and you move on to building the solution. I think the more modern, the more up-to-date ways of developing are Agile, Scrum, and DevOps. So those are the ones that we see a lot now. Just a quick check. How are we for time?
We have 2 more minutes.
Okay, I'll speed up. And then incremental is basically that you start working in a very small a piece of the solution and you build it out, right? So it could also be that you work on several small pieces at the same time. And interactive is, for me, is always the most important one. Is testing with your users. So we can do a whole nother scientific lecture on this one. And just coming back to the user perspective, user-centered design is really important. And what you start from are the user requirements. So what does the user need to work with? And we have different kinds of requirements. Requirements coming from the business. So that can be the entire ecosystem. Requirements come for the technology. We call them the system requirements, and the user requirements. So yeah. That's what will come up in your first stages of the development cycle. And another one is if we talk about agri-food, let's say you're building a use case with wine, with vineyards, and we're talking to a vineyard owner. These are the things that are important from his or her user perspective. So what are the impacts on the farm? What are the goals and benefits for the producer? You need to bring them forward because he or she will want to learn about them. How is his business going to grow? Or why should he spend any time on the project? So the effort that is needed and the time invested is important. And also, it's a change of seasons. The biological growing processes of a vineyard determine how the project's going to go. So I spent time in a project for IOF 2020, Internet of Food and Farm. I wanted to talk to farmers about IoT solutions, and they weren't available because they were harvesting. So of course, it's very logical, but you have to think about it. And a lot can change, even at the level of a farm or at the level of a logistical operator. So yeah, I don't want to, we still want to encourage you to think about blockchain applications, but you see, today we talk about a lot of things that come into play. This is an overview of the different kinds of first versions that you can think about. An MVP is a minimal viable product. So I don't have a lot more time, but it's different than a pilot. So a pilot is really a first version of a full working system. A minimal viable product is the limited amount of functions that you need. So it's really a minimal version. A prototype can even be, a sketch can also be a prototype. And a proof of concept is really proof that an idea works. So I put the link to this in the notes of the PowerPoint. You can check that out later. And then before you have a prototype, yeah, you can have a sketch or what we call a wireframe. It's kind of how the screen's gonna look like, the mock-up. And then the prototype is the first version. So all terminology that you need in an ICT blockchain project. Yeah, I made it a little bit late. So are there any questions? Lorenzo just popped on his video. Yeah, just looking back at this session, I think it's a really nice overview of the ecosystem, the stakeholders, the theory behind it, even the research bit of it, and then how to go through an IT project like that. But yeah, I hope we didn't. You're still encouraged to go on with blockchain.
And I hope you will love ecosystems.
And I think it combines very well with the session in the morning from Koos too.
Yeah.
So it gets more the whole idea of everything.
Yeah, so Koos provided the example first, and sorry for those who didn't get to see that, but it was just a deep dive into one of the proof of concepts that were developed in our project. And now you have, yeah, so first you see what you get, and now you know how we did it.
Yeah.
Yeah. Mm-hmm.
Sure.
Then no questions?
Okay.
Job.
Last chance for questions.
Actually,
Yeah.
I have one.
Go ahead.
So I know that the answer will be not objective at all, and it will change a lot. But what is the cost of a project like the Flory chain, for example, or some other that can be probably with a lower complexity or higher complexity? So and actually the maintenance of the infrastructure to run the blockchain.
I can give you an indication. I hope this information will not be shared publicly.
We are recording.
So it's an indication of this order of magnitude. To develop a software application like you saw this morning, you usually cost between 50,000 to up to 100,000. You can have really fully functioning application. And the value of the time we spend, hours, so consulting time, and also people's contribution in kind, altogether they would amount to more or less about 300,000 euros.
Okay.
So that's 2 years of work involving about 10 people in total. So if you divide all the time spent altogether, it amounts to that.
Yeah, okay. Thank you.
So
Yeah,
I
very
hope you get an
objective.
idea.
Very objective. I
But
was
it's just,
expecting.
but N is one here. It's just one, and it's rather complex use case because we really covered a lot of issues.
Okay, really interesting.
And a very valid question. The business case obviously needs to be clear before you start a project like that. And well, that's something we can cover maybe in a future session, how to draw up your business case. But it's not what I've seen since I started looking into blockchain. It's not always leading. It depends. I mean, for a huge retailer, the business case can be less important actually, because the consumer transparency is just driving the project. So it really, really depends. And of course they have more to spend. So yeah, but it's often a very valid question. Yeah.
Yeah, and I take the opportunity for probably a final question. So, and when you analyze like a problem, there is something that when sometimes you flag that, okay, blockchain here is like the suitable solution for that, or blockchain is not suitable at all for this kind of problem. So there is like some kind of, like when you start to analyze the problem, that you feel that the technology is suited or not for. Of course, I know that that is on the. It depends a lot, case to case. It will change a lot, but probably there are some signs that when you start to analyze the problem, you see immediately that this can make sense or not. Of course, the base of the technology implies that you have decentralized the process and something parts that are not trusting at the beginning. So, and this is the tool, but there is there is something that can easily be flagged to identify if some problem is actually suited for blockchain or not.
There are many flags.
I think it's time to promote our large collection of tools and blockchain scan and checklists, which are available in reports or blockchain scan. I think you got the link before. It's
Okay.
really a quick scan. But in several reports, we have, I think, collected checklists which are typical. What are the typical items we should verify before you even embark on the blockchain research or blockchain application? So a sort of checklist or decision trees, and we'll be happy to make a collection of it. Perhaps we could share later in one of the lectures.
Mm-hmm.
Yeah, some of them may be in the repository, I think.
Yeah, I think you're now talking. I think I browsed at some point with at least one of these decision trees. Yeah.
And also yesterday morning, Gero also had a slide about that, which was interesting. Not specifically agri-food, but more general blockchain use case approach. So that was, or the question that you need to ask. So if there's an audit trail, for example, could be a flag. If there's a data sharing problem beyond one organization in an ecosystem or a chain, that's a flag. And there were a couple of more. But yeah, I think the problem needs to really be unraveled before you can know this per case. Yeah.
Okay.
Okay,
Any other?
Let me just to point out a final comment is related with your open question. How can you apply these topics in your research field? Okay, that could be an open question for working at home for the students. And I don't know, maybe tomorrow or Thursday, we can come back to this question to see if they have some feedback to this question.
Good idea.
Nice idea.
Work at home.
Person
Homework.
with most innovative ideas will win a prize. Take the liberty to announce this.
Okay.
That's a great idea. Thank you, Lorenzo.
Okay, so we are already running out of time, so we can close the session for today. And tomorrow we have the session on the digital layer with the colleagues from Wageningen and IBM. So for those that you are participating in the whole Trusted Summer School, we see you at 9. And for those that are participating in the scientific lectures at 9:30. So see you tomorrow.
Okay. See you tomorrow.
Bye-bye.
Thanks everyone for joining.
Thank you very much, Mireille and Len.
Yeah, thank you.
Bye.
Ciao, ciao, bye.
Bye-bye.